This is a Toho. I finally found my old set of Twitch music that I had. I had them all in a folder somewhere, and I totally lost where they went. So I couldn't find it for the life of me. Also, I don't know if I'm too loud. Hello everyone. How's it going? Beautiful day that ends in Y. It's one of the ending ones. Wait, no, it's not. I'm thinking it's Friday. It's the other T day. So I am very excited for today. I haven't been able to do anything specifically math oriented. Just the idea of math. Well, I suppose this is too. Well, I'm just excited to be here, okay? So, good evening. If it's your time zone, if it is not evening, then good God, what are you doing? And hello. So, hi Tyler. Hi Kami. Hi, Standing. I could have sworn I've seen you before. First time chatter. No way. Just Standing? Really? And yeah, hi. How's it going, everybody? It's a beautiful Thursday night, my time zone. What are you guys doing right now? What is the activity to do right now? Karmamos. Hi, Aleph Math VTuber Fractal Edutainment. Those are the tags. Those are the things. Those are the things that are me. Wow. Have I actually done anything entertaining yet? At some point I am. You're at work. I'm surprised you can even do stuff at work. I didn't. I was just back to back this last few days. Slash LaTeX. It is / LaTeX. So it is LaTeX. You silly. Let's go. Let's go. So we have some really cool. Oh, and I suppose I should share off some of the new features that we have. I didn't make too many. Most of them were just some commands. But if you ever want to make anything huge, we have a chat command. So one of the cool ones that we have right now, we have tons of new raid messages. Nep has one. That's one. That's the one she has. So it makes her thing huge. Let's see. I can name a few people that I know of right now. I'm just gonna say names out loud. Gauss has one. Terry has one. Terrified Games. Penbu has one. Let's see. There's a lurk command. Adipe has one because he was the one that made this entire LaTeX feature. So Adipe gets one. Ryler, you have one. Z has one. Famished Integral if he shows up. He has one as well because he happened to be there during the stream. But we have a funny thing, okay? Yes, you can lurk, you can unlurk. Gaussian service is not the name of the command. I should lower this just a wee bit because I can hear. Z, yeah, Z has one. How do you guys know all these? Does it have a list? I should make the list up, I guess. We have a few funny commands. Poisson has one, I totally forgot. But yeah, if you do something like tech frac, that's a cool one. 6, 7. You guys can automatically type out the arguments. Now, that one's not perfect, and I'm still going to get the kinks out of it because I want you guys to type out like basically a whole phrase to be the numerator. Then you have a big space, and then you have a phrase for the denominator. But no, it doesn't just work that way. Because LaTeX specifically demands spaces between terms. So until then, I will figure that out. I just realized I'm also off center too. I'm like roided up right now. I am excited. It's the weekend. Not really. I have to work tomorrow too. But I'm excited because I'm finally freaking off of work, right? Although I also, hold on. Quick little adjustment. I want to see the author. I want to see who's actually like typing these ones out. So let me see, like the lurk one. Copy this line, and it's gonna say the tech frac one. So I want to see like who's actually typing some of these ones, right? So Tyler, try that again. It should be good to go. Tech huge, also the same thing. So tech huge 1. Which means one argument. 𝖘𝖔𝖈𝖎𝖆𝖎𝖙𝖘. I said that. What are your thoughts on the directlet? Directlet? The dude? I'm definitely not looking it up right now. See, it's been a minute. I've heard of the term. Continuous multivariable probability distribution is named after German mathematician Peter Gustav Lejeune-Dirichlet. That sounds incredibly familiar. I'm familiar with it. It's not the worst thing, actually. Let me get this straight. As long as he spawned up twice in your studies on today in 2 different books. You know what? It's like all of them are a bunch of like popular dudes. I'm surprised by how much overlap is actually happening in math. There's a lot of different individuals just popping up, and it's not even because, you know, Einstein did general relativity. Now we use Einstein equations. No, it's more like, oh yeah, literally everything just came off of Newton, right? Which is something I do want to cover today. Some of Newton's stuff, right? So Newton did a bunch of really cool things. I am very fascinated, especially one of the things I'm going to do today, which is just a little tidbit trivia thing. By trivia thing, I mean I'm going to make you guys do an entire exercise with it. Yeah, Gauss appears everywhere, but you never heard of Dirichlet. Sounds like a chilled out. Dirichlet? I've heard it before. Dirichlet, the dude. I swear he's in something else. If he's in probably multivariable calculus, he's probably pretty significant in like early stage 3D math. I'm looking up his Wikipedia right now. You guys cannot see it, but he's German. That's a one thing. In number theory, he proved special cases of Fermat's last theorem and created analytic number theory. So Fermat's last theorem, I wonder what specific cases he's doing. 𝖈𝖗𝖊𝖉𝖎𝖙𝖘. I don't know what that means, but I will say it out loud. But like Dirichlet, I'm pretty sure. I've probably heard of it in number theory then. Analytic number theory. In analysis, he advanced the theory of Fourier series, and was one of the first to give the modern formal definition of a function. Oh, hold on. Let me see what this is. One of the first to give modern formal definitions of a function. Right? Because function theory is pretty important before you even actually do any math. I mean, that comes back after the fact, and you kind of retrain yourself to do all the cool stuff. You saw him in the Fourier series conditions or something else. I don't really. Cool. I forget what that means. I don't really. Cool. I really recall. I don't remember. That's that Reddit speak. I totally don't know what that is. Let's see. Dirichlet's pretty cool. I've heard of it though. So yeah, he's also went to France, back in Prussia. What? He married someone. He's in Berlin, 1850s. So this is like early 1800s. And then he did most of his number theory stuff in about 1830s. So the 1830s or so. You know what was going on during the time? America was there. America existed. That's cool. I think at the time also just a lot of like lots of number calculus was like really popping off. I think I remember covering that during the Z stream, that some specific calculus stuff was just coming out. But he did stuff for analysis of all things. So I'm not sure about the history of analysis, but I think that's still pretty interesting. He also won a bunch of awards. That's interesting. But yeah, there's lots of things I'm going to cover today. Today, we are going to be covering 2 things. One, I want to cover something new that I just learned about numbers and how they happen to make a shape of 4 sides. Or after that, we can cover some 3D modeling stuff. So we're gonna be doing some 3D fractals, and there's tons of different ways to do fractals, and I'm really interested in trying to create some wacky ones, right? Yeah, I basically meant squares. How do you get the square root of anything? If you were surviving, let's say you were in a dark alleyway, and a random Aleph just comes up to you and starts shaking you, and he says, you need to give me the square root of 75. Are you going to be able to solve it? I don't think you're going to be able to solve it, because at the square root of 75 is just a big number, and you would not know how to get an exact answer up to 5 digits or something. And you're going to die. So I'm going to shank you because you couldn't do it. So next time you do that, you're going to need me. And you would really want to know how to do a square root. Do I know how to solve a square root of -1? That's some imaginary nonsense. I think you're making that up. And everyone's in a group chat that you're not invited to, and it's all in your head, okay? Gaslighting's not real. They're all in your head. It's just imaginary nonsense, okay? Are you okay? You want to talk? You already did the joke in Discord? I know, it's funny. It's funnier the second time. It's almost like it was a joke squared. That's not that funny. Okay, so we're hoping that today we will... I guess I can cover what else I did this week. Math jokes! Ha ha ha! It's pretty good stuff. It's funnier the nth time. It's the funnier the nth time. That's a good one. Okay, yeah. So yeah, today is gonna be pretty chill. I do want to cover what kept me from doing anything. Thank you very much, Tyler, for that. Are you gonna do this right now? I'll have you know that I'm actually having a beverage of sorts. I do have water. I was gonna have some coffee, but then I probably actually should. I don't need to be up early in the morning tomorrow, which is good for once. I don't want to get up early tomorrow, but I do happen to have something in the afternoon, so womp womp. But I do have a beverage as well, so I will consume. I will take until I cannot take anymore. So that should be fun for stream, right? Right? Very wacky stuff. Dad, you really wanted to make a factorial joke first thing in the morning? How? I'm curious what your factorial jokes were. Oh, that's what that was. Jokes factorial. If you wrote it out in LaTeX, I think I probably would have gotten it much better. Jokes factorial, right? Huh. I guess I might have. Okay. Really quickly, I'm gonna cover... I want to see what's on my other side of the stream real quick. I'm not going to talk about DirectLit just yet. Oh, I should also share one other thing that's really cool. One other thing that's really cool. We do have this new plugin, okay? So, as much as I've been covering the theorem of the day, we also have a command for that. So, theorem of the day. TOTD, okay? And we wait for it to call. It will generate an answer for the current theory of the day. And I believe it should be coming up right there. Yeah. Today's theorem of the day, Gödel's theorem. And I wonder if it comes up with different answers. Oh, it does kind of, because it is an AI-generated interpretation of the current theorem. Okay? So only one person needs to do it one at a time. So that's good. We can bring it up later. So, okay, let's read that. My answer was AI slop. Well, you guess what? We can't just do a web scraper on PDFs. Apparently, it's really difficult to actually do text scraping off a PDF. So the only other thing would be interpreting what the actual name of today's is, and then actually providing an answer for it. We can obviously look at the original, but there's so much like actual like stuff that we could do. And yeah, I would prefer it to be more one-to-one to what I want, but it is what it is. It is neat in and of itself. In fact, that it exists in the first place is still pretty cool, because it still looks at the website, it still looks at the actual entry, and then it still provides an answer. So we can still get the like what current today's is, and I can always pull it up and be like, hey guys, let's take a look at this thing, right? If we could refine it without any AI elements, because obviously it takes tokens and it takes a lot of stuff, and not everyone likes AI, clearly, look at you. So, yeah, like, we could probably avoid it. It is fine, you know? But, like, AI, yeah, it makes a lot of sense. Useful sometimes. this is one of the more creative uses you're seeing. Still hate AI corporates though. That's totally fine. I totally dig it. I'm clearly not being like, hey guys, take a look at my AI image. I am an AI engineer, right? No, I'm not doing that. But the use cases for math is just so useful. If I can't just generate random numbers all I want. I can't just make a glove that fits all for everything. If we can make math descriptions, like, let's say it's so good too for like feedback and learning things. This is actually how I learned how to do this by myself. I started out with the idea of learning how to do a square roots, and now I'm going down numerical methods. And that's actually really cool because I knew numerical methods was offered at my university, but I couldn't do it because, well, one, I was already bombarded with everything else, and two, it was an applied class, and I'm not an applied mathematician. I'm actually an AI engineer. I'm not. Yeah, Aleph, not. It's ads. I haven't seen you ads in a while. What's going on? What's poppin'? But like, let's say you want to have a discussion, be like, okay, I want to know how to properly complete the square for a polynomial. I never learned how to complete the square for a polynomial, for anything, to be honest. So I remember it got brought up a few times. We did it for like a proof, and then that was the end of the proof, and that was it. So like, actually doing it by myself, I did not know, because it's not a rigorous thing that I learned, and it wasn't actually something that I needed to cover again, because completing the square is occasionally useful unless you are doing proof stuff and you do factors and all these weird things, or you needed to write it in different terms, or you just wanted to, like, no vertex form for polynomials. I did not know, so why not just let AI do all the helping me understand it in some capacity, at least in a dialogue. So in terms of like science communication, even if it's not like, I'm not talking proofs, I'm not talking physics, I'm not talking cosmic or papers and stuff like that. I'm just like, hey, break this down to me in a way that sounds interesting. You wasted money today, so yay. Okay, let's go. That's huge, guys. Hold on, let's go ahead. Tech huge 2. Let's go. Let's go. By the way, that's a command you can use using my brand new tech commands feature using Stream Elements on streamelements.com or something. .com/dashboard/bot/command/custom. Wow. So you too can use your funny emotes if you want to. If you just want a single argument, you just have to use techhuge1, which, by the way, is a really cool thing that you can do in the chat. Did you know that I like LaTeX? Pretty huge. Reject IA. Yeah, basically. Now, ads. You have to tell us why you lost money. Also, what happened to my music? My music died. So, where to go? There you go. So, ads. Tell us more about your financial grievances. I'm not a statistician. I can't tell you that. I'm not even a financial advisor. But I'm gonna say that losing money is a big bad. So tell us how it happened. And everyone, please be interested, because this is fascinating. Alright? Hype this up, please. This is hilarious. My daughter was sick. Ice cream. Then she wanted to use my phone and dropped it and cracked the camera. Then my wife was like, she needed money to buy some nonsense, like some eyebrow stuff. So you're victim of a series of wacky events. Did I hype this up to be a little too real? I'm so sorry. Oh, that's kind of it's yeah, that's a bummer. No, it went from one thing that was going to be fixing things, and then it went to another thing that was going to be, well, now I have even more issues. So that's, you got to make the most of it. You got to feel optimistic. So that is what it is. I can't, what? Can't believe you hyped up Ad's daughter being sick. Shake my head. I didn't. I didn't do anything. I was merely intrigued by the story, and I'm very satisfied that we all learned the real case of what happened, so we could take it at face value and appreciate the circumstances. Although the scenario we are reacting to may not be appropriate for that. So, yeah, I couldn't say no to her. Oh, that's so sweet. The limit of money being. Oh, what are you missing there? X being money. It's. You don't need to do /limit. Yeah, your tech got messed up because it did the wrong thing. Junie likes having my phone. Oh, what did she do on it? Did she play Angry Birds? I remember that was a thing. You guys ever actually played Angry Birds? I didn't because I didn't get to do. I didn't have a phone at the time. So yeah. Let me fix that one up for you, Carmos. So you don't need to start with the first one. The second one is good. The first limit, you're chilling. You don't need a $sign for the first limit. She does whatever she wants. Well, I'm pretty sure I'm also a dad that... not that I am, but I'm pretty sure I would be a dad that I would never say no. Now, if it was my boy, I'll be like, alright, shut up, kid. We're gonna be doing some math. You're gonna like it. Which reminds me. Oh, that's another announcement I wanted to make. Okay, I do want to play a game soon that has a daughter in it. That's gonna be very exciting pretty soon because it's dad game, if you will. And I'm gonna keep it at that because it is not whatever you're thinking, it's not gonna be. Oh, what is Aleph talking about? Dad Simulator? That's very clearly the thing we're talking about right now. If anything with Kingdom Hearts, no, it's not. It's not Kingdom Hearts right now. Terry's trying to get me to do some Kingdom Hearts stuff on stream, and if I have time for it. I want to do like a randomizer. I freaking love Kingdom Hearts. So if there's anything coming up soon, then we're probably going to do something together like that. It's either Pragmato or Death Stranding. It is, in fact... I also haven't played Death Stranding either. Crap. Okay, you want to know the biggest factor of like things that I cannot do? It is my systems requirements. I am running some fairly inexpensive specs, but that also means that I don't have the highest specs. And I've been meaning to upgrade some stuff in a minute, but that's not going to happen anytime soon. And Junie and Bianca are going to be there. Yeah, I'll be there. I hope to see what you have them in the chat for that. That'd be really fun. Now, there is an ad coming up in about 10 seconds. And by 10 seconds, I mean like now like 3 seconds. So enjoy that if you guys are there. I'm going to look into some things real quick. Because next thing I really want to do... A 2-3 minute ad? What am I going to do? What I mean to do is... Maybe I'll implement a new chat command. That's right. So if you guys are still listening, let me do another chat command real quick about like... What would you guys want for a new chat command right now? Like literally right now. What would you want? Something funny. Kind of put me on the spot there. What are you gonna do? What are you gonna do? Gosh, I should play sax like this. I got nothing. Blurg! Explode! Exclamation explode. Excellent. Okay, let me see. And you're also not on the chat real quick. Let me refload the... Yeah, hold on. What's a good explode thing? What could explode do? Oh, maybe just random chatter explodes. Yeah, let me look up the wacky. Random chatter is gonna explode. How's that? random. So we can do a random pick random chatter. That's how it works. Let's see. Okay, we're gonna do random chatter has exploded. Even more devious, explode be a random vanish. Vanish? What does vanish do? Are you serious? Is that like a? Is that not banned? Is that not like a ban? Exploded. Your mods would not like it. Vanish? What would that do? So like they just aren't detectable? Erases your chat history. Okay, here's what we got so far. Do timeout 7 for a fat 10,000 seconds. 10,000 seconds? Yeah, vanish doesn't work right now because I undid a lot of them. But we could do explode. Someone do explode right now. Explode exists in the chat. If you guys try it right now, explode is possible. Ads has exploded. Let's go. Wait, there's a cooldown on this one, huh? 15 seconds. Okay, so you can't keep exploding each other because some of these ones don't have proper. Actually, now I think about it. So like Blur Gear exploded. Tyler. Yeah, ads you blow up. Integrate. See, that'd be good for something good. You got better though. They told you a life story and you exploded. You know what? I'm sorry. The poor daughter and the ice cream and now the phone. And you know what? To top it off on a Thursday night, actually you explode, right? Karma most, you've exploded. Hey, this is great. You're gonna lurk, BRB. Ooh, do lurk, yeah. No worries. Do your thing, okay? Well, I finally have a lurk command. Thank goodness. Guys, this is actually fun. Like, we can make anything. We can do anything. Do you realize what this means? We can make people our problem. And we can use them for our math problems. Prove 2 + 2. Oh, if I do a prove, that sounds really funny. Because we could do like a random list of phrases. And it'd be like, proof by your mom. Proof by... Because I said so. Piano, something. A piano. Speak. What do you mean? Red circle. Red diamond. Red diamond. QED feels like a proof of by your mom. I freaking love that one. That one's great. Let's see. The other day, Poisson and I were chatting. It was just like yesterday or something like that. Poisson and I were chatting about some stuff, and I was like, I'm super into this analytic stuff. This what do you call it? This applied mathematics. And he was like, well, that's like literally my expertise. And I'm like, is that right? And he's like, then if you're like that, then you're also gonna like something. And I'm like, no, I'm not. Oh gosh, it was so good. It was something along the lines of, you're gonna like this, and I said no. It was a pull up DMs or anything, but it was just such a good exchange because I want to use this phrase right now. Gosh, you're so funny. Oh yeah. We were talking because I was talking about how imprecise stats command. Oh my god, if that happens, I would literally just ban them. In physics, is it okay to not mention here? Statistics is fun enough. Stats should be a no. Yeah, basically no. That's right. I'll do the stats and be like no. Big, huge, no. First order approximations are fine. Okay, first order approximations for square roots in Newton's method is fine. It was great. It's fine. But then I was like, if only there's a way to like make second order iterations or third order iterations a little more practical, because I'm a pure maths guy. So I'm like, I'm over here solving for fractions with like 5-digit denominators, and which I can do with my abacus. Because the whole experiment soon is going to be to do math live, like solve for some things like the square root of things. Square root of like 70 live. Wouldn't that be funny? So I was telling him this, and then Poisson hits me back that he's like screeches and spline functions. Spline function, I don't know. I remember us hearing those in the some stuff. And then I was like, ugh. Legitimately the worst things, those wacky approximations and those error ranges. And followed up with pure math people when I start to calculate an exact epsilon. I'm like, it's plus or minus, shut up. And that sounds about right. Plus or minus your mom. Really damn slime. Really should just let it set yourself. You guys will see it. Let's do a stats one. That'd be really funny. Okay? Plus or minus, gonna cry about it. I think I should do that. Let's see. Stats. And then it's just gonna be huge $sign. No. Hold on. Better yet, double $sign. That's what we're gonna do. Sin x equals x approximations. That's basically it, isn't it? And which, by the way, I was following the square root one. I was looking into how do you actually solve for trigonometric functions, right? So how do you get the sine of like 57.3? Which, by the way, in degrees, that's a 1 radian. How do you find that? You can use the... I mean, you could use the Maclaurin series. This is, in fact, one of the best ways to do it. Now, you could also discover that using the Maclaurin series, the infinite series expansion, whatever the case, it is still got big terms in it with wacky big denominators. So you still need to do division. Or you can approximate it. Maclaurin species. Which, by the way, someone go ahead and try stats right now. The McLaren? No, the McLaren. Isn't that a car? No. McLaren racing. And McChicken. Oh wait, hold on. Let's do the stats, and then we're gonna lower the cooldown time. These things are so fun. Is that a burger? Huge, no. You didn't catch the question? The word McLaren. Isn't it a car? Need this polynomial expansion to hit 1.221 gigawatts, or you'll cease to exist. It's Nepenthes. It's Nepenthes, guys. Nepenthes. Oh, you already did. Okay. Nep has her own. Which, by the way, fell asleep in your chair. I've done that once. I've done that more than once. Let's see. Global command. We're gonna go for 0 seconds just for right now, and then we're gonna go for 5-second cooldown. So, if you guys go ahead and spam. If you guys spam stats in the chat, you guys will get a very fun message. It's like a Laurent. It's what normal folks call it. A Laurent? Laurent series? No. Now, that's gonna be an issue for, like, rewatching the VOD and stuff like that. So there's gonna be... Maybe I should say sender no. So what if we do this? I touch my freaking abacus like it's the keyboard. Which, by the way, I have my abacus right in front of me still. I'm gonna do some math with this in just a second. So, we'll do $sender. You're using the V show ones. I like it. We like it. Okay, now try stats. You weren't looking at the chat overlay? What were you doing? 𝖘𝖈𝖎𝖆𝖎𝖙𝖘. Okay, there. That's a little better because I can actually see your name right next to it. 𝖘𝖈𝖎𝖎𝖎𝖙𝖘. Blurred. Right? Pretty good stuff. Now LaTeX enthusiast and Stream Elements user. The stand user could be anywhere. The stand user. Freaking love JoJo. Just saw a huge and it felt very overwhelmed. Well, yeah, it's not as big. alephmuvt huge. No, I didn't say that. And you can tell I didn't say it because it's not formatted properly. It's $! You ding dong. Get wrecked. Otherwise, I'm gonna send you to Brazil too. JoJo gives you, oh my god. Actually, what's the current one right now? What? This isn't the car? Oh, no! No! Hermit Purple! I love the... I don't even know what the point of it is. I guess I'm so used to JoJo. It's just so funny that it's just... There's an English dub already? You'd be surprised. Hold up there. The English dub has been there for a while, but it is still an opinion of some people's. Actually, now I think about it, when did the English dub come out? Because whenever Netflix brought it over, I believe that's when it had an English dub. So now, as a part of their catalog, they ended up having an English dub, and it's pretty wacky. And all of the funny, cool stand names cannot be used. So, censorship at its finest, guys. It's Big Corpo getting at us again, not letting us enjoy JoJo's Bizarre Adventure. Steel Ball runs anime only, like a month or two old now. Yeah. Man, which reminds me, when it was gonna come out, I really wanted to do a Steel Ball run video talking about this golden ratio. But now I'm in a better position to talk about it than before, so I'm not about to just spout some stuff at the time. Also, I don't happen to have time to like edit anything. So still, yeah. In English, yeah, English is great. The English dub definitely does not have any problems whatsoever. Okay. I mean, it's a serviceable job. It's perfectly fine. It's just not as like ridiculous as, you know, typical anime shonen nonsense. But JoJo would be good. You could do it JoJo. So yeah, we're chilling right now. Let's go ahead and let me show you guys the wacky square root theorem, if you will. How to solve square roots by hand. I asked you guys, if I was going to shake you down in the middle of an alleyway, I was going to stab you if you don't give me the square root of 75, then you're going to die, right? Unless you can provide me a handwritten note about how you can solve for the square root of 75 by hand. Preferably with an algorithm that I can solve by myself, right? Move from chair to bed. Turn Aleph into young male animates protagonist. Like Ash Ketchum.
Wow, I'm on my mathematical adventure, guys. I don't know much about math, but I do know that I like it a lot. I can't wait to learn about what the real world has for math. I can't wait.
First lesson in, it's just calculus 2. Integrals and not even like derivatives yet. It's just integrals. Which apparently for some people are very hard. Would you believe me if I said I didn't have any trouble with it? Trying to be cozy. It's better than would have hoped. That was I happen to be a gamer. I have to be a voice actor. Well, Metal Gear. Like, I remember doing that bit during the Metal Gear stream. Not that I did a stream. I made animated Terry from Terrified Games. Yeah. Thank you for being North American, because using course names is actually that actually understand. Well, of course. I just happen to be. Guys, you don't understand what calculus 7235 is? Gosh, you must be American. Okay. Or guys, you didn't take geometry 5587 2.5? The Greeks did. Ask Euler. Wait, hold on. Who the hell is Greek? Not that. What the fuck? I meant the Pythagorean. Yeah, freaking yeah. They're a bunch of yeah. They're a way to discover it using Pythagorean theorem. Probably because you happen to have some stuff. Euler Greek 100%. You know what? The next bit is just to randomize chat members' names to be either incomplete Greek or some other like language because it sounds ridiculous, right? Wait, what? 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 Wait, what the fuck? That's never happened. What the hell? This whole time I've been talking about how they don't work. What the hell? Guys, what's going on? Guys, cats and dogs are friends. Math is making sense to people. What is going on? I've never seen it just work. I swear to God. I shouldn't swear to God. I swear to you guys. I never, I thought I knew what was going on. That's what I wanted this whole time. Maybe it only works on odd days. Yeah, maybe you only work when I say so. Maybe you only work when maybe... Shut up. Got him. There's gonna be an issue, I can see. Alright, let's change the price to it, guys. Now that it's finally worth something, we can finally do a number bigger than 1. You are funny, madman. Thank you. You didn't know what was happening. Apparently, redeems work. Wait, if redeems work, we can finally have LaTeX. Basically, what I'm doing with the commands, as for like chat, but I want commands that cost money, or I guess money that, or bits, anything. Okay. So with all that, damn it, there's so much to talk about. I'm just over here spazzing out, be like, guys, did you know if I solve the integral of my balls, then you can solve for the mass of the universe? It's like, I gotta calm down. Huge colored, big pee-pee, not big pee-pee. Brilliant. Okay, I was joking. Please calm down. Good job, Tyler. I'm proud of you. Everyone, spam that in chat. Maybe it's the music that's finally got me hyped up because I finally got different music. Guys, I needed a break. This week was a lot of robotics stuff on my end. A lot of brand new kits that we just got. Brand new things that I had to break down, break up, break apart. And we have a bunch of like brand new kits that need some like wear. So all the batteries are charged, all the controllers are charged. They're I already know a bunch of the lessons, but I need to like research more about like care and terror and scalability and all these things, and that took time. Also, I happen to have 2 shifts, so this today and then yesterday I happen to have a shift from like, what is that, 9 in the morning, so 7 at night, with a 2-hour gap, 2-hour state mandated break. Joking about that. No, it just happens to follow the course of the school day. Robotics kits, you work in education. Why do you think I'm so quirky? Why do you think I happen to be so eccentric and wacky and nonsense? That's quite hectic. Yeah, and then imagine traveling site to site with robotics in your car and then setting things up and then tearing them down. Now I have a bunch of kits that need to be torn down because it was the last day of a site, and now they will be sorted alphabetically later. But I'm not going to deal with that right now. It's the weekend at this specific job. If only VTubers existed way back and still working in community college. Right? Well, shoots. I've only... Honestly, would you want to meet a VTuber? You tell me. These dorks are so silly. Right? So yeah, no, it was a lot of work this week, and yeah, no, it is a lot. So yeah, Wait a second. No, you said something. You got to spend time gardening paid today. You went in the garden. You got to play in the grass, in the flowers. Or you're like frolicking around in like very cinematic and romanticized grass fields B-roll footage. Or was it like? Was it like just watching plants grow or something like that? Is that the boring equivalent of like watching paint dry for gardening? You accidentally got seed pods in your hair. I want to say something funny, but I've realized that I'm not so. What am I? I'm not saying I'm not. That's very funny. And I'm sorry that you got seeds in your hair. Are they gonna sprout anytime soon? Why do you think the pitcher sprouts out there? I don't know. I guess so. You're right. Right? That's kind of funny though. What kind of seeds were they? They got stuck in your hair. I'm guessing they weren't acorns. I don't think Nepenthes have seed pods though. Do they? They're pitcher plants, right? Nice 9 bark. 9 bark. I have to look into that. Do Nepenthes have seeds? Yes, they do. They produce seeds typically in a 4-sided capsule containing 5 to 500 wind-distributed seeds. The seeds are usually sown on damp, chopped sphagnum moss or sterile plant tissue culture. Huh. So, is it tiny seeds like my petunias? I'm guessing so. Wind distributed, but that means they're like very light. Ah. Small seeds. I have that too. Okay. Alright. 9 bark? Let's find out 9 bark. Let me pull up a picture of it too. Plant. It's a shrub. Imagine coconuts being distributed by air. You know, in some part of the world, some part of the climate, it probably is how it gets distributed. 9 bark looks like. Oh, let me put this up on. Let's go over to the gaming. My other gaming. The other thing where I do the thing with the thing. Okay, let me do the thing with the thing, and I'll pull up these images real quick. So, here are my chat commands. You guys are going to see this. The theorem of the day, which happens to be, if it's correct, today was about Gödel's second incompleteness theorem. Second, not the first one. And then this is my little article learning about Dirichlet. I remember there's a Dirichlet test. That's what it is. Dirichlet test. Dirichlet test. Series convergence. That's what it was. Convergence of a series, especially useful for proving conditional convergence. That's what it was. Okay, let's see. How do you think the coconuts are carried by swallows? African or European? You expect me to a 12-ounce bird to fly a 1-pound coconut? Yeah, who's in chat right now? Shoot, what's going on? Let's have my music died again because I transitioned the scene. I gotta change that setting. All this to say, ooh, these are pretty. Open new chat image. These are those flower things. These are these 9 barks, huh? They're also red. Ah. Also, let me censor this too because it's bothering me. Oh, this is a nice image right here. A little too far to the right. Let's me move it just a wee bit. Just a wee bit, please. That one looks like a Diablo. A Diablo bush. No, Diablo 9 bark. That one doesn't have. This doesn't look very clear. There's anything higher resolution. What's the deal here? Oh, I know why, because it was giving me the preview images. Ooh. Went all too far to the left. Blurg, I will literally send you to the null space. Cease your nitpicking. Look at the plants. Look at the pretty flowers. Nepenthes, are there any other wacky plant things? You're in an empty bag. Oh, we have an ad starting again in another 2 minutes. Explode me. You exploded Karmamos. Oh, by the way, Nep, we got an explode command. So now we can randomly explode a chat member. So if you explode someone, it will be really funny. That'll ban me for however long the ad is. It's gonna be 2 minutes. Wait, no, I don't know how long the ad itself is gonna be. Probably like 3 or 2. What do I have it at? It's a number between 1 and 10. I'll tell you that. This plant is very pretty. Tyler, please explode. Tyler Null has exploded. That's good. Good job. Well, I mean, hold on. What's the sample size of our chat right now? We have currently a number. We have about 5 people in chat right now. That is comfortable. Wait, is that true? Hold on. Is that true? Right now it says, yeah, we have about 5. No, it's a bigger number because now it says Nep is here. No, I don't know. Sounds like statistics stock. Statistics stock. Statistics Spock. Stats. No, I don't think so, Bucko. That's a population size. Yeah. Okay. If I have 17 marbles, and I pick out one marble, and 5 of them are green, 3 of them are red, 2 of them are blue, and 7 are orange. What's my probability? That's not probability talk. I'm sorry. That's not statistics talk. That's probability talk. Before you get wacky, you silly stinky. You have 17 marbles and you can fit them in your butt. Okay, thank you. I will take away Nep's command privileges now. There you go. I unchecked it. Nope. No more Nep. Hopefully man colons aren't that small, you know. Man colons. Human colons. That one. Can I do timeout / timeout? I can! Tyler. No, your feet is okay, I'm sorry. Let's put that back. I need Nep to pay attention. Okay, let's do some math. Okay? Let me actually do something wacky right now, okay? You guys want to learn how to solve for a square root? We're going to solve for a square root, okay? Here's what we got. I want my creator to be up. Okay. Let us say... And I also kind of want to change the background music, since I actually have options now. What did you say? Can I connect to the remote server? Oh, wait. Okay, hold on. Are you trying to draw something? A minute 30. Okay, cool. No worries. What music do I want? I want my Mickey music. Hold on a second. You're gonna lurk now? Oh, okay. Thank you, Nut, for coming by. Isn't she supposed to stream soon or something? Here it is. Music sound sources. This is gonna go out of the way. I want this. Okay. Of course, the classic part 1. This ad has golden retrievers and a wienermobile. Is that a Dumb and Dumber reference? Excellent. It literally was the ad. It's that's nice. That's nice. I dig that. Now you want that ad? What did you get, Tyler? You think it was a car ad? And you're distracted by the Goldens and the mobile. Got nothing. Oh, you're a sub. You're subbed. That'll save you later. I am subscribed to you. You have reached subscriber status. Okay. Let me describe to you guys what we I'm supposed to do fractals at some point. Don't worry about that. Okay. We want to do a square roots, okay? So, let us say we wanted to take a square root. Give me the square root of a 1-digit number. A 1-digit number. 9, 3. We'll do 9 to prove a point. So, the square root of 9 is going to be equal to what, fellas? This is actually the hardest question in the world. Okay, it's 3. Yeah. Wow. In fact, we know some squares already, do we not? We know 1 squared, which is 1. 2 squared, which is a little hard. So I'll do it with you. 2 times 2, which is also described as doing 2 plus 2, because there's 2. There's 2 for how many? Okay, yeah. And then we add them together. What's 2 plus 2, guys? You're a square. Fish. 5. Alright, we have some real academics in the chat. Okay, 0 and mod 5. Huh? 4, thank you, Tyler. Winner chicken baked dinner, okay? Very good. Now we have some other squares that we have, okay? 3 squared, which is going to be 3 times 3. And abysmal. Forgot how modulus works. Modulus, I'll tell you in just a second. We actually can use that. 3 times 3. Yeah, 3 times 3. Use your calc chat. And by the way, if you just joined the chat, calc is short for calculator. 9. 9. Right? And Deutsch. Ich. 9. No, that means no. 4 squared. 4 squared is a game where you have a square like this, and you guys would be in the squares yourselves. Okay? And then you would throw the ball at each other, and if you catch it, you have to aim it at someone else. Back. That is 4 square. Classic childhood game, 4 square. I never got into it because I didn't have friends. But in math-wise, 4 square is actually a little different now. It's ads. We're talking about classic children's game Foursquare. Yes, you say. Yes, you say. Yes, you say. Yes. I couldn't read the phonetics of it. 16. Okay, basically, we have a few numbers here, but here's the deal. With discrete numbers, we only have specific ones, unfortunately. So, let's say the square root of... Let's do a square root of another number. Another single-digit number. Give me a single-digit number. Square root of something proper. 10 and 6. 2. Square root of 2. Let's do that. Square root of 2. Now, looking at our leading squares, where does 2 lie as a number? Is it between 1, 4, 9, 16, what? Or better yet, let me phrase it like this. It's between the 1 and 4, right? So, 2 itself happens to be between 1 and 4. Who would have thunk it? So, when we take the square root of 1, and the square root of 2, and the square root of 4, we know these answers. So now we get 1, square root of 2, which we don't know yet. Let me put big, giant, don't know on it. By big, giant, I'm going to do it like this. Which we don't know, question mark. That's my question mark. And then we have square roots of 4. Square root of 4 was that 2 thing earlier. So, square root of 2 is between 1 and 2, guys. Okay? Pretty good to know. Now, you didn't get a cookie? No. Sugar's bad for you. You don't get to eat past your bedtime. Okay? The precursor to squeeze theorem. Even worse than that. We don't get to... Well, I guess we do get to squeeze these numbers out. Watch this. Okay? You're nocturnal. That's what I say to myself, but I had to get up for a 7 a.m. shift. BRB, your daughter wants to play. Kingdom Hearts. Kingdom Hearts. Are you going to go back or wait? What's the deal? Are you leaving me? Tell your daughter that Sora Kingdom Hearts can wait. Laughs in second shift. Hey, I had 2 shifts today. Yeah, and have fun, Ed. Okay. So, we know that the square root of 2 is between 1 and 2. So, let's just guess a number. I'm just going to say, let's say square root of 2 is, let's say it's about, I'm going to define it as about 1.5. Post it on Discord. I'll have to check it out. So we have square root of 2 that is between, let's just say it's about 1.5. There is, here's the money, guys. Here's the thing. The square root of, we're going to use this as a guess. Is this some Bronze Age guess and check nonsense? It is, but with a little better because we actually have some formality with the fact that we have derivatives in here. So, once upon a time, you might have heard this cool guy called Isaac Newton, okay? Isaac Newton is a pretty smart math dude. He did lots of weird things, okay? He was probably like invented calculus or something weird, right? Interesting stuff. It might have been also Leibniz, but he has a method. Newton gets a name on this because of the trick that we have here. If I wanted to solve for, let's say, 2 squared, okay? Then I'm going to say 1.5. 1.5. Let's say 1.5 squared. Because I'm looking at this 2, I should expect it to be some number. Right? I expect it to be close to the actual number 2, right? More or less. Newton was a physicist. Fight me. Sounds like a nerd. You're literally confused about channels. Don't worry about it. Don't worry about it. Wait, what about the channels that you're confused about? We're gonna say 1.5 is squared. It's just about 2. So, here's the bragging channel. You guys want to have your bragging channel? Post it in memes, probably. I don't know. I should probably make you guys something for that. Good to know. I'll have to do that after stream, okay? So let's go ahead and see what 1.5 squared is, okay? 1.5. Okay, that is going to be 25, 2, 5, 6, 7. Okay? Then we have 5, 1. Add that together. We have a number that is about 5, 2, 2. 2.25. 2.25 is a close guess for about 2. I mean, it's off by a factor of a fourth, but it's still fine. Well, that's crazy. So, there is a trick. So, instead of doing the number that we want, okay, we have a goal. So, the square root of, let's say our guess, okay? We're going to have a guess number. Our square root, our number squared needs to be equal to n. And this is going to be an iterative process, okay? So, a way that I can describe this is actually by moving this n quantity squared minus n. Well, 2.25 is not the guess. Using 1.5 is the guess. Because you're saying you already know that it's between 1 and 2. So why not just take the number right snap dab in the middle? Computationally is not the worst, so we're going to use it. That's the guess. We're saying it's about 1.5. Now let me actually make it big. Almost gradient. Where's my opacity at? Do I have opacity yet? Do I know that? That's the guess. That's the guess number. So we're going to call that number x0, okay? Which is going to be equal to x0. Okay? So this is going to be an iterative process, which means that we're going to constantly keep checking the numbers in advance. Sorry, we're going to calculate these new numbers with a cool little trick. Yeah, square root to 1.5 is the same as pi equals 3. It is not. It's about that number. It's not far off. Now, it's off by a little bit, by a big chunk, but it's off, okay? So, what we can rephrase this as, when I move this over to this side, then that means this is equal to 0. Now, this here is the basis of my error check, okay? So, the next number I'm going to plug in here, x1, should be a better guess than the one that I had before, 1.5. And actually, if we go ahead and try 2.25, right, squared, what would we get? So let me just show you guys what we did. We did x0 squared minus n, which x0 is actually just going to be that 1.5 that we did. Squared minus n is equal to 0. I want this to be as close to 0 as possible. Close to 0. And I'm going to make it in. I should really have a palette for this again. Calc 1 stuff in it. Yeah. So once we get that 2.25 quantity squared. Sorry. We got 2.25 minus 2. Our error is about 0.25. Right? Huh. Now, the n itself is still 2, okay? N itself is still 2. We're going to constantly check it. But, hey, isn't 2.25 closer than 1.5? Right? About, hey, this is an iterative process. If we're having to learn how to do this, then we are not in the best territory for that, okay? But we're learning. So, how about we take this 2.25? Well, it needs to be close to 0. We're approaching 0. And since it is not equal to 0, vocabulary. You know what I'm saying. I'm not going to correct myself. I'm going to say that we want a number that is closer and closer to 0. So take a look at 2.25 though, okay? So I'm going to do it in, I don't know, cyan, I guess. So we want 2.25 now, and then square it. 2.25, and square this number. Oh no, we have 3 digits, guys. Let's go ahead and solve it though. So we have 5, carry the 2, 10, 2, okay, 10, another 1, so 1, 11, 2, 5. Next we have this 2. We have, I can just double that, so that's 0, double this, 4, 5, and then this is going to be a 4. Is that right? Could take the square root away and from 1.5. Well, that's basically what we did anyway, because 2.25 is closer to 2 than 1.5 was. And then we have our last number, which is 2 again, which is going to be 0, 5, 4. You are gone. Yep. Okay, add these digits together. What do we get? We get 5, 2, 6, 0, 5. Double decimal. So this number is too big. Right? So we have to take away the error, right? So what is actually the true value of that we're comparing it to? 5.0625 minus 2. Well, now that's going to be too big, right? So that's an error of 3.0625. That is way too far. So there's going to be a trick where we can get a number that got closer and a number that got farther, right? Actually doing job. No worries, Tyler. Go lurk. Do your thing. Right? So there actually is a method to use these squares and constantly get something out. So, like, going back to this real quick, we're solving for this equation. Okay? X naught squared minus n needs to be close to 0. Okay? Now, you will not know this off the top of your head, but there is a new thing here. Okay? Maybe I should put this in black, and then I can use white to cover it up. Is this cleaner? Because then I can use my bright pastels and stuff like that. Easy on the eyes. I see. So, let's practice that real quick. 6, 7, plus or minus 420. Does that look good? I guess it does, huh? This is pretty good. All right. Actually, that's much easier for me to grab, like, numbers and stuff. It just happens to be that I'm a very much white paper kind of guy. So, yeah, it is what it is. Cyan. It's hilarious. Okay, now let us consider this then. What we have is we have x. Let me make that thinner. X to the n squared minus n is equal to 0. Next, there is this thing called Newton's method, okay? Newton's method states this particular part. I'm getting better at writing this. That's great. That's kind of cool. I never used to. Oops, I know what happened. The note right here. Yeah, Newton did kind of a bunch of stuff. Newton did the figs are nice. Yeah, right, the figs. He's the fig guy. He was born 25 December or something like that. Yeah, that's when something important happened, right? I should say. I can't say that. He was born on Christmas? Are you serious? This dude. Fig Newton's not the cookie, but a cake. Is it officially a cake? What constitutes a cake? On an old calendar. Oh, really? Well, we refixed it. We fixed it at some point, didn't we? The Gregorian calendar. Also, give me just 1 second. I'm gonna do something behind the scenes, which means I'm gonna lower my mic. I'm just eating. That's it. Okay, I'm back. Are you quoting a song from the 1800s? Blurred? If so, it must have been a hit back in the day. Okay. Blast from the past millennium. Okay, so Newton's method says this, okay? We can find a very good estimate. So it usually is written like this, where you have a function, okay? But you actually don't have the function. So I'm going to cut this off right here. Okay? What you have instead is you have this particular time step and a description of the function so far. Okay? This is your x naught. Okay? You use the slope. Well, how do you find the slope? The slope can be calculated by this really cool thing in calculus called the what? Do you think I should calculate it by using first principles? The limit as h approaches 0 of f of x minus f of x plus h all over h. Should I use that? No, we can't because we're not able to. Well, I suppose we could take the limit like that. Instead, though, well, yeah, we could. So using that information, what do we actually get though? How far forward are we gonna go in our time step? So we have to go forward in some step, okay? In this case, I'm gonna go forward. Let's just say a little bit. So I'm gonna just say x1, okay? So actually using my 𝖈𝖊𝖉𝖎𝖙𝖘. Karma moves, where did they come from? Okay, so we're going to go forward just a little bit, and using the slope that we have, we're able to probably predict the next time interval, the next value. Now, how do we know that we actually... Stream elements can explode? No. It's the... What's the word? Slope. I'm using slang. Oh, okay. That stream is not going to work anymore. Hey, I slope. You're funny. You're funny. Okay. All right, basically, now we have a step right now. x1. And now, if I was saying that this entire thing, though, was going like this, how would I actually know that? Well, the current direction that we have right now will not work. I don't get any like real description of the curvature of it. Instead, all I know is that my predictive slope path is going to go this way. It's going to trend downward. Okay? So that's fine. Now, if I had a really predictable functions like this, I could evaluate that. Okay? So you don't get this, you get this. Okay? Got that? That's fine. Laughing at your repeat instead of Karm's. Karm's joke was louder. You know how it is, right? Tattle null. I'm gonna laugh at Karmithmos's. Okay, that's fine. Tyler's just a louder one. I apologize. Wow, another ad break. What the hell? I'm snoozing that. I don't want to do that. Okay, so Noon's method only describes smooth functions and non-turning functions. Now, the actual method to use this is a little cool. It is using a guess, x naught. This is your first element, okay? Probably also explain is very wrong. Is equal to a guess. I don't know. Right? So if I'm doing my little square root function, x n squared minus n is equal to 0. I need to guess something for the first time. I have no idea what it could be, but a good guess is probably putting it between the ranges of like yeah, putting it between the ranges of some number that I know. So like an integer a and then a b. Okay? So, next thing you do, x n plus 1 is going to be taking our xn step, and then you're going to actually subtract these values. The function at where it's currently at divided by the derivative of the function where it's currently at. And this is xn. Okay? This will give us a predictive path on where to go. Now, if I was to do this with the function, one of my functions right now, f of x is referred to as x squared minus n. Okay? What is the derivative of x? It's actually Karmithmos. You have actually, you have the same brain cells. You actually have brain cells to tell jokes. Who's holding the brain cell right now? I need to know who's holding the brain cell right now. $2x. I'm gonna validate you. I don't think it got lost. Someone has it. Someone go fetch it from like the gutter or something. Okay? Yes, it is gonna be 2x. Wow. So when we plug it back all the way over here, okay? What do we get? Wow, I realized I probably could have used a bigger resolution for this thing. X to the n plus 1 is equal to x to the n, which is still going to be x to the n, minus, what values do we have? Please God, have math, let everyone explode but me. Good job. Yeah, we're doing good. We're doing good. Okay, so when we plug this back into the original function, function is going to be at xn, okay? So we have literally the entire chunk there. I'm going to replace with xn squared. Let me make this in different colors, okay? So this is going to be... This chunk is going to be right here. Okay? And then this chunk is going to be right here. So when I do that, I'm going to have box right bottom. And then box on the top. That is called a what when it's on top? Insert joke here about rolls and nonsense. In bed. It's legit how I took notes when the pace was too fast. I'm chilling. It's called the denominator. That's right. Or if you're in bed, you're called the bot. Okay. So take a look at the bot of this function. This fraction. It's so dumb. It's gonna be 2x. Wow. And then on the numerator, clanker, you're just like super aggro. On the top right here, it's actually gonna be I'm gonna write it x n squared minus n. Okay? A whole chunk there. Oh, and this is also xn. I love this one. I love this song. Stream Elements has exploded once again. The clinker has died. Congratulations, guys. Maybe I should have a cooldown for it. Let's see. Kami has died. Good job. Oh, wait, hold on. If you explode, does that mean you're dead? Actually? Karma moves. Spell it right. No spaces, no gaps, no balls. I exploded! Ah! That's a bit rude, innit? Oh, that's it, guys. Stream over. Stream is over. That's it. We're done. Psych! You... Oh, you're gonna get me worked up, buddy. I didn't know I could explode. I suppose I could. Oh, you're gonna get me so worked up, bud. Oh, bud. Oh, and I gotta pay attention to YouTube chat too, because I gotta make them participate in some capacity. Okay. And we do have an ad coming up. Let me get through this real quick, okay? Made him Canadian. Oh, bud. Oh, fuck. Oh shit, bud. I done blow up. I don't like that, bud. Oh, sorry. We're gonna talk about that. Okay, so let's take a look. If we actually write it all out, what do we have? We have x to the n minus x n squared minus big N, which is our target goal, x to x sub n. Okay? Now, take a look at that. Take a look at that. Take a look at this. What is going on? What can we possibly do here, fellas? Don't worry, we're gonna make fractals at some point, I swear. Okay. What we have here is we can combine this into like terms. You can cancel the denominator with one of the exponent. Well, even better. Unfortunately, we can't because this is a constant, okay? So, if we were to divide this out, we actually have two terms. And that's big no-no. We can't just do that. But here's what we can do instead. Well, I suppose we do cancel that out, right? Let's see what we get, okay? So let me erase this real quick and we write it explicitly. That's the same thing as saying xn minus xn squared over 2xn. And then we have minus. Is it supposed to be minus or is it supposed to be plus? N over 2xn. Okay? Took a million years for your message to not get auto-deleted. Are you saying stuff? You're gonna take a shower? Yes, you went to take a shower. You missed a lot. You blew up several times, so yeah, that is your fault. Yeah, you exploded twice, so congrats on that. Okay? Here's what we got though, okay? We got xn. Let me rewrite this stuff. Let me move it over. And ads going on a minute and a half. And I normally never take notes like this. You think you're trying to use a command? No, it's new. You know you were there when we did that, didn't you? Weren't you? Oh, the golden retrievers again. Okay, so if I write this out and divide it out, distribute that negative, I have is equal to xn minus xn squared over hold on, negative 2xn. And then the negative distributes across, and you get plus n over 2xn. Is that correct, right? I suppose here I can cancel one out, right? One xn is gone, and then this xn is gone. Oh, boy. So this is equal to... What are you guys talking about? The Chipotle stuff? Oh, yeah. You guys have been in outbreak. Sorry. Okay. Let's take a look here. If you guys didn't get to see. I distribute the negative from... It was actually just out here, okay? Xn minus quantity x squared over 2xn minus n over 2xn. And then now we have this. Just open 3 tabs of YouTube on my computer to help you out. Well, thank you. Thank you for the ads and monies. We're chilling. We're chilling. So yeah, well, no, we're doing good. This one? No, we did it. We did it right. Because it distributed to both sides. Anyways, here's what we got. Here's what we got. Okay, we have now xn minus xn squared over 2xn. So those one of the terms cancels. So now if I just write it like this, it is gone. And now the square is gone. Got it? And then now this end has the xn on the bottom. Okay? So now, take a look at this. I'm going to use this red. This term and this term can combine. Can they not? These are going to combine together. So the coefficient here is 1. And this here is technically minus 1/2. So now how do we take if you have $1 and I take away half of your money, half of your dollar, how much money do you have left? Bucko. Lurg, I see it. What? What'd you do there? What? Oh, no, you can't do that. Well, at face value, you can. Yes, okay. Kinda. No, you can't do that. No, you can't do that. No, you can't do that. Nope. Because, you have... Look back over here. xn, you still have an xn in the inside. So if you took out the xn from the bottom, you took out... You still have xn in the front. Xn minus... Because here's what you make. You have xn minus 1/2 xn quantity xn squared minus n. So you're missing this term. Can you do that? No. Here's what we should get. So right here, now we should get positive 1 minus 1/2 gets us 1/2 xn. So that there is good. And then we have plus n over 2xn. You guys see, it's very clear. You don't have to be an Einstein to solve this. You have to be a Newton to solve this. You have to be a fig cake. Following this then, they both have a half. What can I take out? If I take out a half, what can possibly happen? Oh, yeah, an xn, yeah. It gets you 1/2, half of it, yeah, basically. You get 1/2, taking that out. So this first half is gone. This 1/2 is gone too, which means I just have xn plus n over xn. And that all describes the right-hand side, which is equal to xn plus 1. I really need a higher resolution on this one, don't I? You guys got it? So our next time step, take out the 1 over xn. You can't take the 1 over xn. You're going to keep that. That is going to be important for a second, okay? So, what this is, I'm going to go ahead and make a special baloney nonsense. And by the way, most of this I have not learned formally in a class. I am like kind of winging it. I'm like, I learned this bit. I mean, at least the form of it, and I just derived it with you guys. I kind of figured as much. Should really write my notes like this. Keep it in your pocket. Well, how do you use it though? You can't just use things in your pockets without knowing, unless like it's money or a debit card or a condom. I don't know. You could hold on to those things without knowing how to use them. I guess that's why we're there. You know, someone will teach us. But here's what we did. Okay, Newton's method describes a very predictable sloping path. Okay, depending on our time steps, we're gonna be able to predict the smoothness of a curve. So you don't get wacky functions like this. You get predictable, smooth, continuous functions. Predictable. And quadratics, believe it or not, are very predictable, smooth, curving functions. Keeping it that way would be nice if talking to a limit as x approaches infinity. Well, let's see what ends up happening then. That's the case, okay? So, Nepenthes has exploded. Nep is still here. That's good to know. He's actually in chat. I don't even know. So, all that to say, this is the approximate way to find the next square root value, the next iteration of a square root. Okay? I'm gonna be stuck. Didn't know Nep was still here. I guess so. Hello again, ads. Okay, so what am I actually doing here? Is this like note-taking skills? I don't even know. I'm just kind of like, this has been my first few streams doing stuff like this, and we're supposed to be doing fractals after this. So, here I am doing the exact thing that's not in the primary name of the title. Look at me. Whatever. We do the thing that I want. Okay, all that to say, let's go ahead and make the next layer. Next layer has to be black. All right. Yep, stream's over. That's it. Oh, yeah. My daughter was being annoying. What did she do? Which Kingdom Hearts are you playing anyway? Surely you can't expect her to play Kingdom Hearts 1 by herself. So, let me go ahead and write the function. Square, make it a little smaller. Square root iteration. Pay attention, iterates. Iteration. Nep equals adds. Yep, that's right. 𝖘𝖈 main. She loves 𝖘𝖈. So wait, what game are you playing? Which one? What do you play? Which game do you play 𝖘𝖈 as? I'm pretty sure none of them except possibly 3. Is that right? So the square root iteration process comes from this function. We have the next time step is going to be equal to 1/2 xn plus n over xn. Okay? Says how much you know about Kingdom Hearts. Yeah. Kingdom Hearts 3. Okay, I thought so. No worries. Well, then Kingdom Hearts, let's calculate the next Kingdom Hearts title name. Because, you know, we got Kingdom Hearts 0.2. We have Kingdom Hearts 2.8. Right? Do you remember some of these ones? Was it 0.2 or was it 0.8? 2.8. And then we had like Kingdom Hearts 3 just recently. And hopefully we get a Kingdom Hearts 3.5 and a half. 358 days over 2. So clearly they love math. If they're using wacky Kingdom Hearts names. Makes you feel any good. You haven't played it, Kingdom Hearts yet? Kami, you are You know what? I'm gonna call an explode. Tyler's exploded. I apologize. And why was it caps? Okay, so let us actually use this iteration process. Okay, which means that we're gonna be getting closer and closer values of the square root function, the square root value, but we need to understand what this means. Okay, let me label these properly. N is equal to it's the function. Okay, let's say I want the square root of n. Okay, n is the true value, or hold on, no, n is the target. Yeah, I guess so. It's the thing inside the root. Okay, it is the argument. Okay, the thing inside the square root. Okay, xn is equal to our current step, obviously. But x0, let me put in big magenta. X0 needs to be a guess, not a Gauss, a guess. And just to be extra quirky, I'm gonna find a shrugging emoji. Shrug emoji. Japanese. An emoticon. What's been going on here? Gauss's Greek. That's a lot of homework to do. What's been going on? Hold on. I didn't realize what was going on. Okay, Tyler, you died. Daughters, Shadowlands. Catching the consoles. Clearing your backlog, you suck. You gotta play Kingdom Hearts at least like one. You gotta get. Okay, it only takes one console to play Kingdom Hearts, and by one console, I lied. You have to get literally every console to play all the games. Gauss is Greek, apparently. Again, yeah, I apologize. It's an emoticon. Shut up. Okay, so our guess. Give me a square root number. We're gonna do a square root of a function, and we're gonna actually solve for it. Okay. And I'm gonna go ahead and explode someone in the chat. He died again. Singing Kingdom Hearts, the Disney game. It is the Disney. I spelled explode wrong. Karma Moses exploded. Brilliant. I'm literally about to shut up about the math. Let's talk about the chat nonsense. No, we're gonna do a square root of a something. Give me a number. Something single digit, please. Okay, square root of 7. Tyler was first. Sorry, Blurred. Square root of 7. So, trivial stuff, guys. Everyone knows their base square roots, and 7 happens to be one of them. However, we also need to respect the people that definitely don't know their square roots. So, let's go ahead and find out about them. What's going on with my colors right here? Why am I so, like, muted? Here we go. 7 is the most commonly rolled number in a pair of 6-sided dice. Yeah, sounds right. Okay, so we're gonna do the square root of 7 then, okay? Now, some guesses, some very obvious guesses we can do. Square root of 7 Let's take a look at the number on the inside. Does it look like any squares we know of? We know the square of, let's say, 1 squared is equal to 1. 2 squared is equal to 4. 3 squared is equal to 9. So what numbers do you think we're going to be between? What do you think, fellas? We're going to be between 4 and 7. Not just any 4 and 7. The square root of 4 and 7. That's right. Oh my gosh, Tyler, thank you. Just left it as completely by itself. All right. So we're going to be between the numbers 4 and 9. Okay. It's like a, you know, it's like a, if you like a woman very much, you go between her opinions and you tell her, hey, let's meet in the middle. That's definitely what I was going for. Okay. So, what's a number between 4 and 9? What do you think the actual, which by the way, the square root of, I'm sorry, not that. The square root of 4 is going to be 2. Let me put that in this one. This is going to be 2. And then this is actually going to be 3. So square root of 7 is going to be between 2 and 3. So what's a good guess between 2 and 3? It's a good guess. Yeah, 2.58 bad. It's literally smack dab in the middle. That's crazy, isn't it? Right? I'd say that's not a bad guess. Holy schmut. Smut? 2.67. Tyler, I will... Actually, no, that's fine. That's funny, because I did that too. Okay, so our first guess, we're going to use this function over here, okay? So, we're going to be using xn plus 1 equals 1/2 xn plus xn over xn, okay? Which means, for our first time step, we have x not equal to 2.5. So, our function... x1, because it's xn plus 1, right? We're going to be using this formula, this 𝖘𝖈𝖎𝖆𝖕𝖎𝖙𝖘 formula. Okay? Holy schmuck, time to learn Yiddish. I love Yiddish music. I love klezmer. I freaking love klezmer music. Mainly because I played clarinet and I was like super impressed with all that. But I couldn't actually play it because I am buns. No, that's not true. I auditioned to music school and I failed. So that's why I became a mathematician. Also, Aleph lore. I went into math because I was like, well, I can't do music anymore. So I'm just going to do math instead because it was so easy. And sure enough, it was easy. A wind instrument nerd. I'm going to roll and explode one more time. 𝖘𝖈 has exploded. 𝖘𝖈 has died because of you. Maybe you did the same thing. You went into physics because of that instead of music. I feel it. Okay, let's take a look at back at our function. 1/2 xn plus n over x, the thing. Okay, so let me write it out because actually I need to write, take the average of our current x value, which is x naught, plus n over x naught. Okay? Having fun with the explode. It's funny. Randomness actually adds a lot. So actually, I'm gonna do some more stuff like that in the future. But I knew how to do it. I just didn't know how to like make it funny. You guys make it funny, not me. In music school and decided to take a hiatus and lost your chops. Your chops. I'm guessing you. Oh yeah, you music. Tyler, you exploded. You killed yourself. Good job. I should really have a sound effect go off when that happens. It'd be really funny to have a sound alert, which clearly they work now. Ridiculous. Okay, so x1 now, we're going to go ahead and plug in the value of 2.5 here, okay? 2.5. So I'm going to actually leave gaps here. 1/2 plus, and we're going to do, we plugged in 2.5 divided by 2.5, okay? Oh, and n, by the way, I suppose I should explain. N is our target, the actual number inside the square root that we want, 7, okay? So 7, n is equal to 7. These color coordination is so awful. Blurg, how do you do it? N is equal to 7, okay? So So now I'm going to go back here and I'm going to plug in, what's the shortcut for switching? I just really need to grab a palette. Grab any color, use MS Paint. That sounds right. Okay. Let's take a look though. Computationally, we have to find this fraction. 7 over 2.5. Oh no, 7 over 2.5, that's not a convenient number to divide. I don't want to do long division and do 7 divided by 2.5. I don't even know my multiples of 2.5. Even easier than that. We are not going to write it like this at all, because this is awful. So instead we're going to do 7 over 2.5 is the same as, we're going to make a multiple so that this becomes a whole number, just for a trick, okay? So how can I make 2.5 into a whole number? Blurg, you already said it. Say it out loud again. And then call an explode function. Nep has exploded again. Multiply top and bottom by 10. You could do it by 10. But here's the issue. Times 10 times 10. Okay? You do that. You get 70 over 25. Now, 25 isn't a bad number because we actually do know its multiples. They are predictive. However, just to make it easier, yeah, let's go ahead and reduce it, okay? How do we reduce it? We are going to divide. We could always just, divide stuff, but no. The reason why we chose 0.5 in the first place, because it's a really good multiple of, because the second we double it, we are just going to get a whole number, right? So we're going to get 5 on the top, on the bottom, on the denominator. And then we're going to get a 7 times 2 on the top, which is going to be what? 14. Oh my gosh, this looks like a significantly easier number to do than before. So what we're going to do is now divide, okay? Destroy the decimals and go from there. Yeah, this is the equivalence of rationalizing the denominator. Now, the only issue is that we're multiplying when really the trick is to just move over your decimal, right? So you guys probably remember this when you did percentages and stuff. Let us say you have, I don't know, 0.815, and you have like, I don't know, a 1 on it, okay? 1 over 815. We can't just do this. This seems like buttons. We're not going to even attempt it. But if we want it in whole numbers, we are just going to move the decimal over, aren't we? But if we do that there, we're also going to do that here. 1, 2, 3. So that means if I move it over 3 times, I'm going to get 815 on the bottom. And then on the numerator, what do we get on the numerator? What's that 1 going to be? Tell me now, or else I will explode you guys. I will destroy the decimals. 100? Wrong. You are wrong. Everyone point and laugh at him, because he's wrong. I gotta really, explode target command. Looks like 1,000 to me. Ha, shucks, because look at that. I actually moved over from after this decimal place. 1, which fills it with a 0. 2, another one. 3, with another one. Uh-oh, you were wrong the entire time. And you suck, and your dog died. That's so awful. Okay, so now this is in terms of whole numbers. Now, it's still not easy to actually divide it. So, womp womp. But we at least have a way to describe it. This is me being very particular with the numbers. But you could say this is kind of close to 1,000 over 800. Which at that point you can get rid of the zeros. This resolution is killing me. So that's just about 10 divided by 8. So that's where you start rounding some stuff up. Okay, 1,000 divided by 815 is just about the same as saying 10 divided by 8. Right? I don't like to guesstimate, so I'm dying. So I prefer this answer, even if it's computationally going to be wrong. Galaxy brain, I get it. The last 100 is silent. 815 became 8,000. Oh yeah, huh. Yeah, okay. So actually it was supposed to be it's just about the same as saying 1,000 divided by 800. Cross. The same thing. I did the thing. Still at 10 over 8. You stinky. You really got me there. Streamer brain, it happens. I was right the whole time. It was still 10 over 8. You stinky. Okay, whatever. Alright, let's go ahead and divide 14 by 5. Let's get this stupid thing over with. 14. Let us start reducing it. I know it's during add time, so that's fine. Okay? 5 divided by 14. What do we get? Just because something is true doesn't mean you have to say it. I'm going to say the first thing that comes to mind, and I'm going to say exclamation point explode. Alright? That one's a good one. I like this now. Okay? It's exclamation point explode. Blurg has exploded. So much, so fun. Skill issue. Did you guys see that? You guys see that? Because it was just in his face. Okay. So, I know it's during ad break. Let's go ahead and divide 14 by 5. So, how many 5s go into 14? Let's count our 5s. 5, 10, 15, 20. Yeah, we don't have to do that one because it's so easy. Yeah, 2. Yes, so we're going to do subtracting 10 out. We get 4. Now, we're going to go into our decimals, okay? So, we bring a 0 out. We bring that down here. 5 divided... How many 40... How many... Yeah, how many 5s go into 40? 8. Yeah, okay. 8. Wait, what? 8. 40. Yep, that's right. And then we can get 0. Remainder is 0. How convenient. How many 40s go into 5, though? I'm not gonna do the whole thing. About 0.12. Wow, amazing. Wasn't that cool? I can't. This is on a. Okay, let me emphasize. This is not a drawing. This is not a. This is not a. It's a. It's not one of the monitor tablets. Okay, it's just the little Osu one that I have because I don't know. I just got so used to it now. And this is good practice. Wow. Do you at least have a stylus? Of course. That's how I'm doing it. But I'm not looking at my hand. I'm just feeling it off the screen I'm looking at. Osu, nerd. I should really do another targeted command. I really need to do. Another ad break? Holy shit. Oh, never mind. It ends. It ends? Ends in a minute. You can get mixed up. That's how you do it. Yeah. Okay. So let's go back over here. Our answer was 2.8. So now that's going to be this chunk. Okay. After this, we're going to go into... We're going to do one more practice, and then we're going to go into fractals. Okay? You're making all the money today. Yeah. Apparently at my detriment, because I'm stopping because I want you guys. Do not want to use fake AI assistants. Go away. Oh, those are the ads you've been getting? Brilliant. Okay. Let me go ahead and put this back here. Also, let me go ahead and make myself a little key. I think I got to start practicing this right now. Okay? Because I can't zoom in by my hand. Okay, maybe that's something I gotta have a template for, and then I'm just gonna have like a palette. And the palette will all have the numbers that I have, so that I can start drawing them really fast. Right? It's just gonna be in the sides and corners of the entire like screen, almost barely. And then I don't know, the golden ratio. I just picked it from the color key on the side. And then we get vomit snot green. Hierophant green. Okay, that's going to be equal to 1/2 2.5 plus 2.8. Okay? 2.5 plus 2.8 is equal to what? You can fix the resolution issues, making the canvas 5,000 pixels across. When did that get there? Oops, I lost a layer. There you go. What'd you say? That's good enough. You know what? Don't listen to me. I'm not making any sense. It worked out. I just did something. Okay, whatever. Let's go ahead and pay attention. All right, so we got this. What's 2.5 plus 2.8? 2.5 plus 2.8 plus 2.5 plus 2.8. Hold on, I have a calculator. Okay. 2.5 plus 2.5 carry. 5, 6, 7, 8. That is going to be 58. Holy smokes. 53. I'm at 53. I have an abacus, and I've learned how to use it. Yeah, 5.3. Wow, I really nailed it out of the park with that one, didn't I? $5.3. You haven't learned how to use it? Don't worry. I'll show you why I learned how to use it, okay? So, we have 5.3 and we're going to cut 5.3 in half, okay? So, we have this entire answer right here. It's going to be eliminated to be equal to 1/2 5.3. Which, believe it or not, it's the same thing as just saying divide by 2. Holy smokes, long division again. 5.3 divided by 2. How many 2's go into 5? 2.65, that's about right. Are you using a calculator? We get 2 2's going to 5. 4, subtract that out. 1. Bring down this 3. 2, how many 2's go into 13? Decimal. 6. Right? That's Spanish for 12. Subtract that out. And then we got 1. And then we bring that down. 2 divided by 10. all the wrong phrases. 5, and then 10, nothing. 2.65. Holy smokes. Okay. So our guesstimate answer for the entire thing here going to be about, it's going to be equal to 2.65. What? So is, and we won't know yet, please don't tell me. The square root of 7 so far, or I should say x1 is equal to 2.65, which is, I'm going to assume, close to the square root of 7. Okay? What? Freaking 2.65. You're not even saying it right. They learned all this back before 9/11 when dinosaurs walked on Earth. What is 900? What? 7.6? 7.6? I feel like I'm crazy. Who's the weirdo right here? Who's the nutcase out here? All right. All this to say, this 2.65 is a bad answer. It's not the best answer. It was senior in high school when it happened. Calculators are highly discouraged. I bet you also use a fax machine, nerd. Okay, so all this to say this is an estimate for the first iteration of this function, okay? So we got to make sure that 2.65 is not the best answer because it sucks. So we're going to go even further beyond a square root. x2. We're just going to take x1. I'm sorry. 1/2, because look back at our function. 1/2 x1 plus n over x1. Okay? Now, all this is going to be... you wrote your papers in cursive, and I bet you had to read an analog clock, too. It's so cool. Okay, boomer. Basically. I'm calling it an explode command. Good job, Tyler. You're on my side. I bet you were until that happened. Nerd. Born before JFK got assassinated. The times you're talking about aren't adding up. Wait, no, they're not adding up. Kennedy got assassinated in 63. In 1963. Which means you would have been in your 50s or 40s. Oh, your parents. Oh. Never mind. Here I am thinking. I thought is gonna be the old thing. Well, you still are, basically. Yeah, boomer. That's fine. Okay. So take a look. So now for the next iteration, we're gonna be using 2.65 for this. 2.65. Oops. 65 plus. We still want our target of 7 divided by 2.65. Okay? Got it? Now, there's several ways we can tackle this. Okay? We can guesstimate our answer of 7. So we could literally do the trick. 7, 2.65 is going to be the same as 700 divided by 2.65. 265. Now, who knows their base 265s? Who knows their multiples of 265s? Come on, guys. You learned this in school, right? 265. Come on, let's go. So it's 265. And then we have, we're going to have 3, 530. Okay. Then we're going to have 795. Come on, guys. You know this. 53 times 5. I suppose so. You could reduce this, or better yet, how far off is 265 to like 2.5? Well, you know what? Just for the poops and giggles, okay? We're gonna divide this by 5. What do we get? Okay, 700 cut in half. 35 0. Okay. Did I say 0 or 5? Sounding dangerously like a physicist. Believe it or not, I was 3 classes away. Guys, I have 3 degrees. I think I need to emphasize, I have 3 degrees. I am a little smart. Okay, two majors and a minor. But still, I was 3 degrees, 3 classes, 3 degrees, in fact, probably. 3 degrees from 3 degrees. Oh, that's a good one. 3 degrees from 3 degrees. You in grad school? No. No. I'm doing this to go to grad school, though. I took a hiatus. I took a break of about 3 years, and now I'm back in business, and I'm still overstimulated from that long ago. I don't have money. I don't even know how I'm going to afford it. I don't know what school to go to. I have until later this year to decide to go back into school and then go into it by about 2027. Because modern year currently is 2026. Huh. Isn't it strange? Also, I just realized I can't divide this in half. And if still TA. I can't TA unless I'm in a master's program. Oh, wait. If you want to extend, you get a stipend. Doesn't I get money? If I do, then that'd be very handy. I would like that. Well, actually, yeah, maybe not, because lots of recent developments have changed a lot of things. For better or for worse, I just think shit's funny. So, we are not going to guesstimate 700 and 265. We're going to guesstimate about 700 and 250. Okay? So we're going to be reducing that a bit. So you get 70 over 25. And then that's just about the same as dividing that by 5. So 5 on the bottom, because I know 5 squared is the denominator. 70 divided by 5. Let's go through our... what is that? No, I'm not even going to tell you guys. That's 14. Okay? Let's divide 14 by 5. Let's go. Hey, look, that looks suspiciously familiar to something else we got. Just about 2.8. Maybe that's too far. Maybe that's too close. So, 1/2, 2.65, plus a guesstimate of also 2.8. That's going to get us an answer. I'm wasting space. 2.8 plus 2.65. Divide this out. We get 5. 8 plus 6 is going to get us 14. Carry the 1. 5.45. Now cut this in half. Okay? 5.45. Divide by 2. I'm getting hyper-focused. Keep getting interrupted with calls. Don't let me busy. You're in class. Yeah, basically. So you got 2. Subtract 4. You get 1. Bring this down. We got 4. We get 7. Okay? Subtract that out. We get 0. Bring this down. We got 5. Okay? So subtract that. We get 4 because we get 2. And then after that, we get 1. And then we should leave it there. We have an answer of about 2.72. Hydrates. If I wanted to do 2.725, that would make sense. Let's just go ahead and keep that in then. Okay. Does this sound like a better answer to the square root of 7 than before? And I am definitely hydrating. Well, maybe not hydrating. I'm detoxing. Okay. 2.725. Yeah. Now, is the fun part. I get to just bring out my normal calculator and I'm gonna say, hey buddy, what is 2.725 times 2.725? What's 2.725 squared? Oh my gosh, that is an overestimated answer. That kind of sucks. Of 7.425. So squared is going to be equal to 7.425. That's too much. We must iterate one more time. So, bottom line, we can't do anything unless we keep getting decimals. That is the main issue about using these things, is that we have to make sure that the more decimals that we have, the better answer we're actually doing. Because we're expecting to actually get a right answer of a square root without going into more decimals. We have to use the decimals. So we can't keep decimating things. We have to actually just straight up use them. Okay? So that sucks. We're not going to do that. We have to do more. So I'm going to use this step, and I'm going to use it in a vacuum. Okay? I'm going to say this is our guess. Okay? And that's going to be x naught. Okay? So this is now going to be x naught. 2.725. Sounds good? So I'm going to create a new layer. Which never ends. Well, tell you what, if we did it the proper way, my answer would have been more accurate up to this step. But I'm going to use this right now, so I'm going to say x naught is equal to 2.725. Because I was going to prove a point about needing the decimals and maybe needing to divide by fractions with big decimals, which means that you actually have to do the thing with the thing with the thing. And then I'm using an abacus to actually do it. Driving home. How dare you tell me that? That's fine. Let me explode you one more time. Watch this. I'm not going to try it. My luck has run out right now. I'm not going to guess it. Okay. So we have a decent... Yeah, see, like you're exploding that. Good job. Good job. She's still here. Isn't she gonna sleep or something? Okay. Who can tell me what... Hold on. We have... To use our function, x1 is equal to 1/2 x0 plus n over x0. Which means, if we're looking at the square root of 7... n is going to be equal to, let me just rewrite it. 1/2, 2.725. Okay. 2.725 plus 7 over 2.725. Okay. Who knows how to, I'm not going to use a calculator to divide this, because the whole point is to not use a calculator to actually get the square root, because this is the method of getting the square root. We are not going to just be doing that. That doesn't make sense. So let's see how we can do it by hand. Okay? 7 divided by 2.725. I can bring this up again. 1, 2, 3. Decimal. 1, 2, 3. Okay? Which means we make this into 7,000 over 2725. Okay? Or am I multiply by 40? You know, I can multiply you by 40. Or you speak to me again. Wait, 𝖘𝖔𝖈𝖎𝖆𝖎𝖙𝖘. Oh, that's a new name. You're right. Hello in the chat, I suppose. And then I wonder how YouTube is doing. Hello, strangers. I don't have YouTube chat on the stream, so if you guys say anything, I'm going to pay extra attention. Okay. All right. Let's divide this out. Okay. Who knows their base 2,725s? Okay. 2725. So, I am not going to go through my multiples. 1 times this, 2, 3, 4, 5. Luckily, I wrote a program just to prove a point. Otherwise, we would have to use I used an abacus by hand to actually calculate some of these things. And it's actually pretty interesting. Yeah, so 2,725. To get the most accurate answer, you would have to do that. They give it like 27.25. $27.25. That would make a lot of sense, huh? Money, get it. Times, so 1 times this. Okay? Cents and cents, exactly. Okay, let me actually go through my multiples. And one day I'm gonna pull up a hand cam stream, and I'm gonna show you my abacus trick because it is actually not too bad. Okay, so 1 times 2725. Okay, so I'm gonna pull up. If you can hear it, ASMR streaming, I suppose. Okay, 2725. Actually, this is a pretty good number to add 4. Maybe that's the trick. Maybe there's all sorts of things that you can use. Thank you, sir, very much, Blurred, for explaining an accent. Yeah, so can you hear the clicks? I'm only doing this because the other day, or the other week ago, the other month, Z started her cuneiform streams, and I was very fascinated to be like, oh my gosh, cuneiform was describing base 60, and how are they actually adding these things up? Well, they could write it out, or they were using an abacus. But yeah, let's see, this is just a wee bit too close. Maybe I could do that. And also, yeah, I'm American. Like, we don't use this. 2725 is a really good number on an abacus. I'm using the 9 base one. So let's go ahead and just go through our multiples real quick, okay? 2725, I'm gonna add 2, 7, 2, 5. That is already 5,450. 5,450. 5,450. 5,450. So 2, 3, 4, 5, 6. What am I doing fractals again? 7, 8, 9. We don't need 10 because we don't ever get a 10 times. Yeah. They did form an, hold on, not even joking, you do ASMR with abacus, I just said that. They did have a form of an abacus, the clay board with little divots, with little pebbles around. Wait, why wouldn't they have just used, no, because it's a development, a technology. Duh. I suppose so, huh? Okay, 5452, and again, I'm gonna add another 2725. So hold on, 2, 5, 6, 7, 2, 5. That is 8,175. 8,175. Okay, 2725. 1, 2, carry. 7, 1, 5, 6, 7. 2, 2, 5. Carry. So that gets me 10,900. 10,900. Straight up. If that's not right, correct me if I ever make a mistake. Is 4 times 2725 equal to 10,900? No, I'm using the abacus. Yeah, I really can't express how interesting this is with an abacus. I'm basically just going through my multiples. 4 times 2725 is equal to what? Four times 2,725. Nah, yeah, okay. We could split it up. I'm not splitting it up. I don't want to split it up. That's not the point. 8,280. 2,800. 100. I was right. I was right. And again, this is actually a really good number to add. Anyways, ideally, you go through all these numbers. I'm going to suspect that you're going to have a 7 in here. So we're going to go through a few more and just get through them, okay? 10,900 plus 2725, okay? So again, 27, 1, 6, 7, 25. That is 10,365. 10,000, or was it 13,625? Easy. Let me also change the music because it just looped. So let me go to, because I'm definitely not using the playlist. 5 times 2725 should be 1,360. 10,000. 13,000. Damn. 13,625. Yes. Check it.
Check it, 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 check it.
Yeah, that's good. Okay. Is this correct? Okay, I'm gonna do it again. 2,725. 2,001, 2, 7, 5, 6, 7, 25. So that is 1,600. That is 600. That's 16,350. Yep. I'm gonna do. Hold on. 10,900. So I can clear my calculator. I want to click. Was that wrong? Was that wrong? Hold on. Was that wrong? 10,900? Hold on. 10,900 plus 2725. 20. 1, 6, 7, 25. That's, yeah, 13,625. I was right. Made me second guess. I got a little good at this because I was practicing by myself, but this is like basic arithmetic, so it's not the hardest thing in the world. Not yet, at least. Forgot how to add. I'm trying to get to 7 because I'm pretty certain it has a 7 in it. Otherwise, it would suck. Gonna get to fractals. I swear we're gonna get to fractals. Okay. So let me reset my calculator. 1, 6, 3, 5, 0. Okay. 27, 25. 25, 6. Crap, hold on. 6, 7, carry. 25. I did that correctly. Yeah. Okay, so that is 1,900 and 10,000, 19,000. 19075. 19075. I should really just say that. There you go. Okay, there you go. Got it. Okay, 2 more. 2,227. 2,000. Yeah, no mistakes yet. 2,725. 2,725. So 1, 2, 5, 6, 7, 2, 5. Easy. That is 21800. 21800. Okay, and then the next one, 21800 plus 2725. 25672 That is going to be 24525. 24525. Got him. Okay. I think that's it. We need our multiples because we're going to be dividing. Okay? This is how they did it back in the day. We're going to do it the hard way because this is learning. Okay? This is learning. So, now let us go through 7,000. How much does 2725 into 7,000 equal? By the way, I could have just definitely reduced this into smallest terms, and I chose not to. They didn't have Indo-Arabic numeral system. Well, yeah, no, they were using different base system entirely. So, yeah, I don't know. Base 10 is pretty handy, though. You know, we have 10 digits. That's why we use base 10. 10 digits literally comes from the name fingers. Oh yeah. When algebra got invented, they did some really cool stuff and reinvented everything. Fibonacci actually played a part in it. Fibonacci was the bastard who reinvented the number system because he made everyone started using Roman numerals. I'm sorry, Arabic numerals, not Roman. It's okay, Kami. Yeah, 𝖈𝖗𝖊𝖉𝖎𝖙𝖘. Yeah, the name of the guy who made the name algebra. Is that right? Or was that the is that the square root guy? The squares. Perfect squares. Completing the square dude. 𝖈𝖗𝖊𝖉𝖎𝖙𝖘 is the algebra is algebra. Arabic numbers like Indo numerals? No? Oh, wait. Did they? They are? Hindu philosophy and origin? Interesting. Okay, really quick. What I'm gonna do next is I'm gonna long division by 2,725. We know our multiples of 2,725. Everybody knows these. Okay? So, what number, how many 2,725s go into 7,000? Okay? That's the question. What is the closest number we can get to 7,000 without going over? It's weird that Indians who invented Arabic numerals called their number system something else, and then Arabs adopted the system and called it Hindu numerals, and then Europeans got it from the Arabs and named it Arabic numerals. I mean, Chinese remainder theorem, if that's true. I don't know. Everything else has a funny name, doesn't it? Okay, so let's take a look. There are let's take a look. 2,725s that go into 7,000. Okay, so we're going to say 2. Subtract out 5,450. Luckily, I have a handy dandy abacus with me. So I'm going to write out 7,000. I'm going to find my decimal place. Hold on. 7,000. Subtract 5,000. 1, 2, 3, 4, 5, 0. That looks like 1550. Subtract this out, you get 1550. Okay? how many? Let's go to our decimals. 0. How many 1550s? How many? Yeah. Okay. I'm just gonna basically do the math on it. Okay. So we can do 5 27 25s. Okay. So that is 13, 6, 2, 5. Subtract that out. So 13. I'm over here now. Move over 1 decimal place. I'll show you how you can do that in the future. So 1, 2, 3, 5, 6, 1, 2, and then 5. So I get 1, 9. I'm at 1,800. 1,875. Okay, that sounds good. Well, you could start guesstimating, but the whole point is to not guesstimate things. They had the technology at the time to use this, so I'm pretty sure you were allowed to use it, use these. I mean, they were not just for accounting; they were also used for fast arithmetic. That's why even now they still, abacus still exists. You're here to pick it up. See that the pick was 5. Yeah. No, it's got to be a number that is as close to the answer, but not it. So yeah, 1875. Okay. Now we bring down another 0. And I can see 2.5 is actually a really bad answer for this. I would have been done with this a long time ago had it not for something in particular. It's probably like 2.65 something. And actually, I did do square root of 7. Oh, I did square root of 5. Tell you what, pretty soon I'm gonna probably do a few more digits, but I don't want to actually. I'll have to continue this from next time. How's that? Because I don't want to lose track of this project. I really want to do my my stuff. So I'm gonna save this as square root math. Let's go ahead and just wrap up the night by doing the actual thing I labeled this project as, which is doing 3D modeling. I just happen to really like this square root algorithm, and I'm really fascinated by numerical methods right now. So I'm very interested in bringing everyone down like a rabbit hole with me, but it also is just literally turned into 2,725. That number is going to be in my head. Midnight for my end. So let me be smart with my time. I do happen to need to work tomorrow. So give me just 1 second. Yeah, it's quite a night for me. Sorry about that. Okay, I'm gonna go ahead and hide this, and we're gonna go ahead and look at some Blender stuff. Okay, this will be the first phase of several different phases of me showing you guys some really cool 3D art I can make. Okay, let me lower this just a bit. I actually do want a different soundtrack to play. So Blender, you are gonna now show up Fire hexagon. Yeah, that's my layering. Okay. I do usually like these soundtracks, but I'm gonna have to play something different. You guys like Pokemon? I'm gonna play some Pokemon. Alright, vibe change. So, I am now a chill, relaxed streamer. We're here to learn about the shapes and stuff. Okay? Hold on. So, one of the cool things that I am digging right now, you can get beat up for playing Pokemon. Wait, what? What do you mean? Best is making nasty differential equations into discrete algorithms. Solve the recurrence relations. Just do it. Weirdly enough, it came out too late for me. Pokemon. You should try it. It's really good. It's pretty good. Pretty yums. Okay. So let me show you one of the cool things that happened with a fractal. Okay. So one of the ways that one can make a fractal in 3D. There are several different fractals that exist in nature. Most of them are pretty natural or biological. You mogging and chocoboing? I dare you. So let me show you an example of a fractal, okay? A fractal that I can look at right now. Hopefully this doesn't pull up the images right now. No. On my polar movement sequence. Very nice. Okay. So if you take a look at this one real quick, this is actually a part of the burning ship fractal. And what's cool about this shader too is that I can actually just change the values on it. So any value that I see on it is, I can change the color ramp. In other words, if I want the whites to be I can change the hues and stuff like that. And since it's a pretty discrete fractal, it's not going to be really bad. But yeah, this is the part of the burning ship fractal. Over here, this one's got a cool name, and I'm also going to put the emission on this too. This one is called the 𝖈𝖊𝖉𝖎𝖎𝖙𝖘 fractal. Okay, the 𝖈𝖊𝖉𝖉 fractal is pretty neat because it's just a path tracing algorithm, and it unfortunately means it does not have a curve or does not have a mesh. It's path tracing. So you iterate the paths over and over and over again. And again, I can change the colors if I want to, but I won't. This right here is a reiteration of an iteration of the I believe another part of the burning ship fractal. So instead, actually, let me look up another bit. Let me look up I think this is part of the Mandelbrot set. Okay. So these curves are usually what you get from the Mandelbrot set, and from this particular one, this was taken from coordinates negative 0.206 points, negative 0.2076, and then y0. So pretty cool end right here. Anyways, we can't do path tracing fractals in 3D because these are not meshes. Okay? None of these are meshes. Okay? These are surfaces, if you will. That is why they have their own special categorization, and we can barely find the points that are in them, and they are points, by the way. So we can generate a mesh using the points that we get inside the set, but they are approximations of the set. Otherwise, things are also really dense with like number data, and loading up number data and polygon data at the same time is actually going to just crash stuff. So yeah, it's a little hard. Early CGI mountains were fractal, no? Were they? I probably believe it. Iterative, yes, but up to certain levels. This has like millions and billions of points, right? Most of these ones. Early 70s and 80s, yeah, probably. I believe you. And then these iterations, like these take a time step. This takes you like tons and tons of like iterations to get a smaller window, because this window is actually really small. This window is about a 0.25 width and then 0.002 height. Like this is like really tiny, or whatever the case. So how do we do meshes in 3D? That's the question. What is an idea of a mesh we can do in 3D? Well, we can just think of doing a model and making it do something at every coordinate point, okay? So let us say, for the example here, I have a cube, okay? It is the default cube, so I will delete it, and I will create it again, okay? You won't get that joke. To me, it's hilarious as hell, so pretty funny. So how many points, how many vertices are on a cube? How many vertices are there? You know nothing about most software related, so you assume everything is hilarious. Just laugh at face value and everything's going to be pretty normal. Yeah. Okay, 8, right? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so what if, let's say, at every single corner, I want to make a smaller version of the big thing. Yep, you can. Hopefully that doesn't go away. Let's say I want a small cube, but I want it to be at every single corner. So instead of me manually doing this, just like those Blender tutorials. I'm sorry. Alzheimer's in your family can't make a guarantee. I didn't exhale nose out of my mouth because I thought that was funny. Not the same size though. Well, we can make it a proportion of the size. Okay, I'm making it worse for myself. So let's go ahead and start with the mesh right here. Okay, here's what we can do. There is a special feature in Blender here called geometry nodes. So let me just explain many of the tons of things that you can do in Blender. Blender is a physics simulator. Okay, so you can actually run physics sims. So let me emphasize, this is a box. So time step, let's go back a bit. And then the bounciness of this thing. So Blender can do lots of things. This is also... Okay, it's a physics simulator. Accelerated down, noise. Yes, yeah, that is because gravity is down. I can go to the world properties right here, and I can change where gravity goes. Okay? Gravity is no longer point, and you can't see it very well. Gravity is no longer 0.8. Negative 9.81 meters per second. And let me move my little head for you to see it. I'm changing this little thing right here. Let's just make it... No, actually, let me just make it 1, just to prove a point. Positive 1. What will happen if it's positive 1? Gravity is down. My family is validating Newton. Down is stupid, because down is perspective. You ding-dong commie. How dare you? If I say gravity is +1, where are we going? Are we going to be going up, or are we going to go down? There's a whole system, unit system of particle physics, where most constants are set to 1. Well, gravity is here, and what's going to happen? Just answer the freaking question. Is it going to go up, or is it going to go down? Or I'm going to call explode. Stream element says broke. Okay, no, that's actually going to go up because it's positive 1. You imbecile. How could you not know? Everyone knows this. So instead of messing with the parameters, you're right. Negative 9.81 meters per second. Yep. Yeah, so that's what I was asking. Short-term memory. I guess so, huh? I apologize. So here's the deal. You can do physics simulations. You can do really nice shaders and stuff. So I can make this thing glass if I wanted to. Glass. And by glass, I'm going to have to use some properties. Standard. Transparent. And then some other things. Rough. Noise. By factor. I want it by factor. You literally have shampooed your hair right now after shampooing your hair. Are you okay? I apologize for that. RSDF. Shader. You just laugh sometimes and forget, it's so silly. Principle, that's what I want. We are here to enjoy everything and have a good time. Make shader. So you can't see it very well, but what's supposed to happen is that this thing is supposed to be a lot more rough than it's supposed to. Or clearer. I'm trying to go for clearing. I'm pretty sure this is from Pokemon Coliseum. Well, Coliseum and XD Yellow Darkness. Or maybe XD. Specifically XD. Don't you know? It's silly. Now, if we change this to cycles, it'll probably look a lot better. Yeah, there we go. We wanted refractions. So, are you guys familiar? You might not know this very niche band. Let me see. Maybe not. Okay, hold on. Yeah, okay. So, look. You guys might not know this band. let me start with this. Eliminate these. Actually, everything about that. How is this still a cube? Oh, I guess so. Let's see, you guys have ever heard of a band? They have the little like light thing coming on the side, and then a little rainbow comes out. You guys happen to know that band? Led Zeppelin? No, they're a little more unpopular than that. Pink Fellas or something like that. That's what they're called. I don't even remember because it's a dumb name. But anyways, yeah. So you can have shaders, and then the light would go in here, and then it would, it doesn't reflect properly, right? This isn't a physics phenomena. You can't just make things work. But this is functionally what it does. Light goes in. Led Zeppelin does an immigrant song. What is it? What? So depending on the index of refraction, it starts making things. Okay, what does this have to do with any of the things I can do in Blender? I will eliminate this. I will eliminate this. Okay, back to adding the default cube. So lots of things you can do in Blender is what my point was. Now, one of the things you can do is called geometry nodes. Okay, geometry nodes is a special feature where you can manipulate things about the vertices and the cool things that happen from it. Okay, so let's take, for example, I want the points. Okay, I want the points mesh to be points. So I have a special property here. I take my mesh exactly how it is. All the point data that exists, I'm going to turn it into just point data. So when I feed it back in, I will just get the points out. Now, for math, do you think that sounds like something very, very handy? Can I just say that I've only begun to learn advanced math because you left high school and your approach towards math has made it more interesting for me? That is actually very cool because, like, as far as I understand, everyone wants to be dry, or they have this pedagogy where it's just like, hey guys, let us learn about the number 2. The number 2 comes after the number 1. Like, okay, I get that. Like, come on. Like, tell me actually the thing. So I'm kind of like barfing at you with everything that I know, but I'm also like hustling you guys to be like, okay, you should know this. If you don't know this, tell me you don't know this, because then I can tell you what that means. Like, come on. The whole point of teaching is to learn how to. And I'll tell you what, I am kind of a teacher, but I am not a studied teacher. Does that make sense? Edutainment. That's kind of the bit, isn't it? Hey, funny math guy, be the teacher on TV. Well, hold on, I have a bit for this. Let me also make myself much larger. Hold on, I gotta do like. Okay, I do have a bit, and I'm gonna do something live right now, but I have to change the song, and I gotta keep track of where my libraries are. So it's actually in a tucked-in library, so I'm gonna save the shortcut to this here, and then back here, I know where to find the current song. Okay. Okay. Hi, I'm alephmuvt, and do you like math? Well, believe it or not, I'm a math guy, and here at Math Entertainment, we are here to teach you all about math, okay? One of the most fantastic things we could do with math is make it fun for people. Now, you probably are familiar with the boring math on the screen all the time, and you don't know what's going on because you're just taking notes and you have to solve the exam. Now, that's no fun. Instead, you have to think about math as a plaything. You know how to read. You know how to write. Well, why don't you math? That's right. With mathematics, you can do everything, like 3D modeling or being a weird anime boy on the internet. You can do anything. And that is right, kids. And if you just call the number on the screen right now. That's right. The number is just 1. 1 is a very important number, and that is my number. Number 1. If you call the number 1 on the screen right now, you will get yourself 2 different different homework sets. The first one will be for basic math. The second one will be for your doctorate degree. You can do this now, or you can do this never. You call the number on the screen. You have exactly. Ooh, and look at that. The number that it is just ended. Thank you so much for joining me tonight, and you will be here with me next never. Thank you. Bye bye. Bye bye. Bye bye. That is the bit. That is the. Down to 1, you got voicemail. Okay. Yeah, I think that's a bit. I only have enough energy for like one of those things, and it happens to be in the middle of the night. Of course it does. I hope you guys enjoyed that. That was pretty funny, right? That was pretty funny. Let me see. Where is the? Okay, back here. Actually, no, that should be the bit. Someone clip that, by the way, if you didn't clip it. I'm gonna change back to some music though. Yeah. Can't even sub to skip the ad. What happened? You hold on. Let me see. You didn't get to see the funny bit? Shucks. It's gonna be on the VOD, I guess. Damn it. Some Eurobeat sounding stuff. This is actually from the Toho Jazz playlist. Well, can I gift a sub? Oh, you're referring to the promotion. I hope that was pretty good. I really couldn't think of anything on the spot, so pretty alright. Yeah, no, math is supposed to be funny and entertaining. So if you're just boring, just saying stuff by yourself, it doesn't make sense. So how can you make it boring? Anyways, I'm gonna take the dual of this. Okay, what is the dual of a mesh? Hold on, let's take a look at the mesh by itself. Now, a dual, which you probably have heard from geometry. The dual is, let me show you this. So you see here, all of these little vertices right here. This is actually the center point for these faces. Okay? So if I can, a trick I can do is I can, what's called poke the faces. Yes, you can poke the faces. It's like a, oopsies, I did the wrong thing. Poke the faces. So now all the center points have something. If I connect them together, oh, that's a bad example. All adjacent vertices will get a face, and then all adjacent vertices will get a face. Adjacent vertices will get a face. This one will get a face, and then don't forget the top ones. The top ones need that too. Now, what shape does this look like? Now, if I get rid of all the junk on the outside, so, I'm looking for points. These are gone, these are gone, these are gone, pentagon. Hide these. What shape does this look like? It's a D6. Oh my gosh. So, let's actually discover. This is called the dual, okay? The dual of a face is you poking all the things together, and at the center points, and then connecting them because they are adjacent. So this side, let me show this. This side is I'm gonna call 1. Let me actually change the color on this. 1. This side over here is gonna be called 2, and this side is going to be 3. So because these are connecting together, and I wonder why it's in 3D like that. Oh, placement. Oh. Surface. So, 1, 2, 3. Ah, that's actually what I want. I never knew how to learn this. Learn something new stuff. Interesting name for the shape. So it's the dual. The dual, okay? Now, some really cool things about the dual. By the way, I'm not a geometrist. So what you learned was just me manually sculpting this by hand. So instead what should happen is the dual eliminates everything else and keeps everything here. Okay? Hold on. Okay, now I got my cube back. So yeah. So if I can actually just do that all in one step right here. So if I take the dual of an object and then I put it back in here. Whoa, look at that. Isn't that crazy? What? That's crazy. I turned a D6 into a D8. Now what do you think will happen? I'm going to duplicate this. What happens if I take the dual of a dual? What do you think will happen? Do I get a bigger number? Well, so I turned a D6 into a D8. That means the number went up. So maybe, I don't know, there's a chance that it could keep going up or something like that. So, do you think the vertices will increase by 2 or something? Or what do you think will happen? Vote on your phones now. Stupid guess is up by 2. There's a chance. Kami needs to participate. Otherwise, I'll explode. Doubles. Maybe. You guys are thinking with your brains. Kami, I will literally... I'm gonna explode you right now. Nova? Nova? You've been here the whole time? Nova's my artist. He's the dude that made me. What's going on here? Guys, go over and follow him now. Nova's been here. I just happened to discover he's here. Oh, that's a good way to get lurkers away. Oh, that's my dad. Yeah, he's my dad. He made me. Officially, not concept art wise, but asset everything wise. So take a look at me. He made the art for me. Okay, my little long hands, you know, all the assets and things. My toesies, my little shoot toesies, right? But the design itself comes from something else. And also all the art assets and everything. Yeah, you like my shoes, my little boots. Believe it or not, they are up. They're supposed to be 10-fold naughtiness, but if you count the number of intersections, it's actually, let's count. So there's top 1, down middle 2, down that one 3, 4, 5, 6, 7, 8. There's only 8, so this is an 8-fold naughtiness knot. So yeah. The assets in the hair are very nice. Yes, I like my design because it's actually very simple. Well, fairly simple for what it is. But it's intelligently designed. I really like my design. It's really cool. And I didn't know Nova was here. Go follow Nova. Nova's amazing. And really funny. So, yeah. Really cool. I really like how I turned out. And I have my little assets and everything. Or I could do this, you know. 6, 7, 6, 7, 6, 7, 6, 7. So, yeah, that's pretty good stuff. Anyways, so let's go ahead and take the dual of the dual now, or because you know I'm a scatterbrain. We haven't even got to any fractals yet. I really should have set this up for today. What's my time limit? Should really just focus on this. There we go. Okay, so let's take the dual of the dual. Okay, the dual of the dual is going to be a very familiar shape. We know this one, and I'm gonna lower myself as well. And I'd be guessing correctly because the fatigue is getting hard. All right, that's fair because we gotta get through some of these. Okay, so lots of cool things I can do is that I can keep taking duals, but it turns out it just ends up making the exact same shape. That's the whole point of calling it a dual, is that what ends up happening is the shape just becomes exactly itself again, right? So although it's smaller by a factor, but it's still fine. Anyways, that's not what we want. We want the points. Okay. So here's what we need. We need an instance on points. So all the points that you see right here, all these little things right here are the visualization of a point. Okay. So if I add an instance on points node, that means I get to just make something appear exactly where those things are. So how many vertices again of a cube do we have? We have 8 vertices. So if I can make all those vertices have something drawn on them, I want something simple, like, I don't know, a sphere. I'm gonna do a UV sphere. I'm gonna do not a big one. I'm gonna do an 8 by 8. What is that basically? Is it hold on, what does that look like? That works. So all the points that you saw before have now become where I made an object become. So where it says here mesh instance, that's the thing that actually becomes those points. So if I was to do this in like a scripting program, I could get the data from those points and manually draw an object onto it. And I can pre-render the object if I wanted to. In this case, I happen to have a lot more control because, you know, check this out. I can change the vertices as I go, segments, the rings, the radius. And hey, look at that. That might be important for, like, I don't know, crystal structures or some nonsense like that, right? What? What's crazy? Crystals? And even better, take a look. Because this is still fully functional as a... And I don't want to be in cycles anymore. Eevee. This is still fully functional as a mesh. Because this is still a cube. Phonons, baby. What? This is still fully a cube. So I still have these vertices and I can move them around like that. So instead of doing that, I can actually do something cool. What's something called shape keys. Shape keys tell me that I get to take my current vertices. My current vertices exist, and then what I can do, my current vertices, I can transform them. So let's say I don't want them to be here. I don't know. I want the top faces to spread out a bit. And then I want these bottom faces to, I don't know, go to a point. So I can make that happen with a slider now. So now if I just slide them together, they will still be that shape. Because behind the scenes, it is still just that. Because let's say I don't even have this geometry, it's still just this. Isn't that interesting? What could I do with this now? So basically, I have control over the vertices, and also not just that, but edges, faces, and any sort of shape that I want. And I'm making a generalized thing for it. And this is only the beginning of things that you can do with this. So I only put spheres on the ends of everything. But I don't want spheres. I want something more practical. I want the actual geometry to go back into the geometry. Okay? So to do that, though, I need to scale it down by a factor. Okay? Now, what I need to do next, what I really want to do, is I want to do a bool. Boolean. It's mesh boolean. So I'm gonna take these cubes and I'm gonna subtract them from the existing mesh, and then I make this. So that is one iteration of a fractal. Okay, one iteration. All I did is I took these cubes right here and I cut them out from this shape. And this is me also kind of just winging it right now because I know what to do, but I'm also experimenting live and it's working out. So, oh my gosh, look at that. And because I have a certain scale factor, let's do 0.752581. That doesn't mean anything to me. That doesn't, I don't think that is anything. 0.747 though, I think is a real number. It says square root of the 1 over the square root of 2, I think. Yeah, so I mean, shoot, it's working. What can you do? What can you do? It just happened to be entertaining. I don't know. Hey, Aleph, square his balls, and yeah, I don't know. I can do anything. So, anyways, this is one instance. So what I'm gonna do here is I'm gonna do a group. What a group does is I get to make this entire section, and then I get to have it as just one group, one thing, one instance. So now when I duplicate it, I copy all the steps I just did, which was, hold on, go back. Edit group, which was I turn all my points into a mesh. So all of this point data you see right here, all of these corners are going to become points. And then at every single one of those points, I'm going to create a smaller version of the thing you saw. And then on top of that, I'm going to cut it out. And then I'm going to be making it exist there again. Now, I just realized there's a flaw in my logic here, because I don't want to use this exact geometry, because it's actually going to get very complicated. So instead, what I want to do is, instead of the instance of shapes, I'm going to just create specifically the shape that I was cutting out, which was a cube. And I will still use the same proportions and everything like that. So that's the case. Was that 1 point? Because I'll show you the difference of what happens later on. 1.5. Oh yeah, I'll mess with that later. Shape key, you are now eliminated. Okay, so basically what I'm saying, instead of going back and using this exact shape again, which could get more complicated, I'm just going to use the cube to cut out all the vertices at these corners. So when I go back out and leave this group, then when I add this group again, that doesn't seem right. Oh, it's using the wrong thing. Cube. Maybe I should use smaller shapes. Something happened. Looks like your brain feels right now. Yeah, huh. Okay, now I'm gonna regroup this. Make group. I'm gonna leave the group. I think there's an issue with the logic here, and that's no one's fault. So, I'm gonna do the opposite of what I wanted to do, which is the cutouts. Actually, wait. Hole tolerance. No. No. So there's a way to make it work better without messing up everything. So instead what we're going to do is we're going to go back in here and we're just going to add faces. And nothing else. Welcome home, Tyler. Damn, that was a long drive. You're okay? I know what a long drive is too. That's a bummer. Oh, wait. If I want exact, that's good. That's what I wanted. So, hold up. Let's go back out. First iteration says we get this. And I go back in here. You caught us in the middle of making some stuff. Okay, good. It's slower on my end on purpose. I'm going to save this file as Fractals. Okay. 1 hour, 15 minutes from work. So fun. I'm guessing at this hour is no traffic, which still is abysmal. Hopefully the pay is worthwhile. Shoot. I can totally understand that. I'm gonna guess so. I wouldn't know. I don't know your time zone. I'm gonna say, yeah, I don't know. 𝖈𝖊𝖉𝖎𝖎𝖙𝖘. Are you Jewish? Gonna exit. And now, hopefully this doesn't brick. He joined them Yiddish words. Fair. Dang it. This isn't working out. So I'm going to have to figure out the kinks of this. Or I think I know the kinks of it. I'm like only an hour of traffic, but they're doing some construction this time. Okay. I feel that. That's not right. 𝖘𝖔𝖈𝖎𝖆. This guy. This guy. Get a load of this guy. Oh, also Tyler, you totally missed my my very legit advertisement. Which, by the way, I'm so disappointed you guys did not clip it. I'm gonna have to clip it after the chat, after the fact. Incredibly disheartened. You guys were like, man, I don't know how to do math. If only there's a funny math boy to like talk about these things. Do I have to do it again? It was way better because there was two people still in chat. 𝖘𝖔𝖈 there. Yeah, 𝖘𝖔𝖈 was there. 𝖘𝖔𝖈... Where did 𝖘𝖔𝖈 go? I forgot. Learnt new stuff. 𝖘𝖔𝖈 hasn't responded in a while. 𝖘𝖔𝖈 did. I'm going to assume so. It just blew up. Yep, done. Done. That's it. Done diddly. Eliminated. If I change the order. You missed it? Hello, Nep. I made a really hilarious, like, ad. And it was, like, actually probably one of the funniest bits I've ever had in a while. So I had the energy to do it for some reason. I'll have to go through and I'll probably have to edit it myself. Because I thought it was really funny. Wait a second. Wait, that wasn't right. Hold on. Yeah, this goes here, mesh goes here. No. Mesh goes here, instance goes here. Oh, let's make these a little... in and out of sleep. You have to figure out... What are you doing here? You should relax and sleep. I mean, thank you, I guess. I didn't know you were going to be sticking around. Wait, that's not good at all. Oh, what happened? What happened? What happened here? Vertices? The cubes are crashing. Out. Oh, I know why. Stay awake and learn math forever. It's like that one Dexter's Laboratory meme. Omelette du fromage. 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 Eat me. Tyler, you want to say something? This isn't what I want at all. You're 90% MSG. I've had MSG. I really didn't have that much hype for it. I'm not gonna lie. It was good. Don't get me wrong. It was good. But I didn't actually have too much, like, oh my gosh, this is the best thing ever. I was like, yeah, that's good. I even sprinkled it in my noodles and everything. I was like, okay, let me give this like a real try. It was good, but it wasn't like die hard good. You know what I'm saying? Anyways, let me do the other thing that was much better. So I'm gonna turn this into points. Mesh to points. And then this here. And then this here is gonna go over here, but the instances I want is just gonna be the same geometry going back in. It's just want it to be smaller. And then I actually want to join mesh geometry. And I do have an add, and oh, that's been add. Okay, this is the easiest instance that I can do, and I can not duplicate. I can make this a group, leave the group, and I can duplicate. My computer has crashed. Listening to math and falling asleep. Thank you, I suppose. Why are you here? Nepenthes. Amazing supporter and friend of the channel. Nepenthes. Do I really have a soothing voice? Alright guys, today we're going to be talking about fractals. Did you know that fractals killed my father? And I'm looking out for vengeance to kill the main fractal. The first iteration, if you will. Fractals start very simple, but end up being very complicated. And that's what my situation has become. Like, what are you talking about? Is it really that good? I don't know. I'm just memeing. And I also live like this, so I don't even know. And also, if you didn't understand that bit, I think that was actually really well made. A really smart bit. My computer seems to have crashed. Or it's actually calculating everything. So I'm going to show you this once because, let's see. If we put an instance of points every... It's mainly my computer is also just calculating a lot of things. And also running every single streaming thing on the back end. So isn't that funny? Hold on. Let's do the math here. So what did I do? I put 6 more vertices on top of every single vertex. So let's do the math. Why don't we? Shoot. Okay. Okay, while that thing's crashing. So we have a cube. As best as a cube can be. I'm going to start with something like this. So I'm going to start with a... I'm not going to round it this time. And on a separate layer. So this is a cube. Do you agree? This looks like a cube right now. I want it. That is a square. Holy smokes, that is a square. You think you're right. Okay. Quick little trick right here. What I'm going to do now, I'm going to do a line. Horizontal. Yeah, close enough. Yeah, close enough. It's not even going to be the same, I'm going to be honest. Should just use the lines. Okay. I'm going to find out what happened. So, how many vertices does this square have? This cube, excuse me. How many times does vertices have? Let's count them. 1. Hold on, I'm going to use red for this one. And we still have this section. Oh, wait. I can also use line for that. Dotted line for this. Spacing. It's a way to do it. Whatever. Yeah, I'm living life. Don't you guys have to sleep or something? Observe. Then we have this point right here. Okay. So we have how many vertices right here? Let's count them out alphabetically. Okay. We got 1, 2, 3, 4, 5, 6, 7, 8. Okay. So not only did I just make a smaller version of every single vertex you see here, so I also created, use blue, a small vertex, small cube on every single vertex right here. Okay? Which adds how many more vertices? Now, this one vertex gets how many things? Use the Boolean to remove the extra cubes. Well, you would think so, but that doesn't happen that way. Boolean actually creates more complicated geometry than that. So we add another 8 for every single vertex, right? So I think this is a math problem. Okay, let me double check that Blender did not crash. Hello? Okay. So we already have 8. Now we're going to add how many more vertices per vertex? So let me phrase it like this. If we had n many vertices, which in our case we have 8, we're now going to be adding 8 cubes, right? And 8 cubes means that we add 8 vertices. So we have n times n vertices. Which in this case is going to be 8 sets of 8. Uh-oh. What do you think the progression is going to be like with this? Yeah, it's almost like it's going to be... Well, let's count them up. What is 8 times 8 here? It's going to be equal to 64. Now, that gets fed. And actually, you were wrong, because it also includes this set, too. It's recursive, right? Which means we actually have another set of 8 plus 64. And then we are going to add that many 8 more. Okay? They're additive. And is that true? Hold on. It's not. So that is actually, you think that's the case. N squared, n cubed. It is not, because it's additive. It's like interest rates. You have to add it no matter what. You cannot automatically include it in a way that makes sense. I learned it the hard way. You cannot just use additive functions to make interest rates work. You have to use recursive functions. So in this case, it looks like it's a recurrence relation. So you're going to be adding whatever many points you have and then multiplying that many points into 8 cubes. No, it's all good. It's not intuitive. So I'm going to call this little bit right here n. That's going to be our base. That would start with 8. Okay? N is equal to 8. Sigma naught is going to be equal to 8, if you will. And I'm completely making this up as I go. So, hold on. Sigma 1 then is equal to be the first iteration, which is going to be 8 plus 8 sets of 8. Or in other words, n plus n sets of 8. Sigma naught. Which almost sounds like, hold on, let's write it in terms of that. Sigma naught plus sigma naught many? Is that necessarily true? I think so. Sigma naught. Sigma nuts, brilliant. I'm gonna ban. I'm gonna project you from, I'm gonna reduce your dimension by 1 if you say that again. Okay? Okay. Next one though, sigma 2 is gonna equal, it looks like what sigma 1 was, and again, adding sigma 1 many points 8 times. sigma not many. So it's not squaring it. It's going to be a function where we're starting with the recurrence relation. And I think this is the math of it, actually. I'm completely deriving this right now. Yeah, pretty weird. What's going on with this? Sigma 1, sigma 1, sigma naught. Sigma nuts. That actually does sound funny. You live this time. So, sigma 3 is going to be use all the points from sigma 2, which is going to be sigma 2, plus sigma 2 many sigma naughts, because that is the base. Okay? Are you quoting my words back at me? So anyways, I think this function is probably exponential. I think, yeah, it's definitely exponential. Because I think these end up becoming constants to itself. Primitive clipping. Ha ha ha. Hee hee ha ha. Let us continue. And I'm making this as I go. I didn't know I could take such alright notes. Ho ho. Okay, by the way, it finished rendering. Let's take a look at it. So, yeah. Oh, it's still calculating. Okay, let's actually go back and calculate how much we actually did then. So, again, let's go ahead and plug in our numbers all the way back up here and all the way back up here. Okay? So, we started with sigma 1, which equal to sigma naught, which is 8 sets of 8 sets of 8, which equals what? 64 plus 8, right? 64 plus 8, 64, 5, 6, 7, 72. 72. Counted with my fingers because I didn't want to do anything else. It's a decent trick. 72. Okay, now sigma 1 is 72, which means this here is going to become, write it in big, by big I mean small. So we have 72 plus 72 times 8 vertices. So 72 plus 72 times 8 is equal to what? 72 times 8 is equal to what? 72 times 8. 576. And then we're going to add 72 to it. Which is equal to 648. I don't see why this has to be so hard on it. So then let's go ahead and plug in 648. 648 plus 648 sets of 8. Okay, that might be something. Times 8 plus 648. That's a measly 5,832 vertices. That doesn't seem right. If it's struggling this much, what's the deal? Well, it's not because it's not because the number of vertices is the issue. It's the number, it's the way it's calculating it, which is mesh generation and all the things behind the scenes which make it actually run properly. So let us, because I can't even pull it up, let us observe where we're at right now. And usually these things should not break like that. Okay, so what I'm gonna do, I'm gonna go back here. Where did Krita go? Okay, I'm gonna go back here. I'm gonna eliminate this task, and I'm just gonna have to remake it. Unfortunate. Because I think it crashed just straight up. force close it. Oh, that is like, it is like extra scuffed. I think we would one iteration more. Wait, in which case? 5,200... 5,832? It's equal to what? Oh, okay. 46,656. And then we also have to add the base 5,832. Which you can't see on screen. Well, that looks like a bunch of stuff that happened. Let's load it back up again and hopefully it doesn't break. Because it doesn't. Well, I can see why geometry nodes is a very difficult thing to work with. So this is the back at the last thing we did. Here we go. Save this, just to be case. Oh no, just something straight just crashed. I know. That's the case. Well, okay, hold on. Yeah, no, this isn't hard. The iterations aren't breaking it. The ray tracing might. Okay, what I'm going to do now, this does in fact work. Are you guys checking this out? So what I'm going to do next is I'm going to get a shader and give it an ambient inclusion shader. Did I put it in the wrong thing? I did. Material 2. Yeah, no, it just straight up crashed. I guess that was it. Because there's no reason... Because let me actually calculate the polygons. There's a thing here called statistics, which I hate, but We have... okay, let me realize this real quick. You shut your mouth. It gives me the numbers of objects, vertices, edges, and polygons. So it's really convenient for the math end of it. So I can tell how complicated the model is without breaking it. Oh yeah, I can't apply modifiers with... Oh, which, by the way, look at this. Oh, I know why. Okay, there we go. So, just like what we did with last time. My only issue is I'm not using the mesh itself. But that can get really complicated really fast. So, and I don't think that's quite right. So I think what's meant to happen is just another instance of it. Or I guess it does anyway. Now, does this have ambient occlusion on it? Okay. So this... Oh, everything is lagging. Wow. Okay. This is pretty interesting. I'm like eating, I'm sorry. So what's cool about this is that the mesh itself is feeding. Every time I move it, this thing makes me lag. Holy smokes. Hold on, watch this. Ready? Ready? Whoa, lag switch. Lag switch. Ready? Watch this one more time. Whoa. Okay, let's bring down one more iteration. No, that's a shame because they're actually really good. Oh, that's crazy. That's hilarious. Okay, that's a different way to do it. Like switch be like. So I think what I'm going to do right now, I'm going to give it a shader, which is probably going to crash my computer. I'm going to attempt to take a picture with it, and then I will promptly go to bed. Track 2 empty. That's pretty good. Ah, Suzu. Okay. I guess I gotta stay up now. Hi, Zuzu. Hi, Raiders. Good evening, night. It's, let's see, what? You weren't doing the Pocky stream tonight, were you? What are you doing today? what could possibly be the occasion tonight now? I am, well, hello. My name is alephmuvt. I'm a Fractal Math VTuber. I am currently doing not a math thing necessarily. I am doing a 3D modeling thing, which is in fact Fractals. And it has crashed my computer, or it's crashed once so far. So hello, I am currently, of course, being a Fractal Math VTuber means I should know also how to do some Fractal stuff. And that is today's stream. If you guys want to see me check this out. I get this really cool thing right here where I have a slider on this thing. It's called a shape key, and if I transform it, all the little shapes are also going to change too, and it's basically like a lag switch. So watch this. Whoa. I guess there was pretty good. So yeah, pretty cool stuff. I'm trying to get a really good picture so that I can have tonight, and I'm making making it just look really pretty. So what did you do? What did you end up doing? Tell me, please. I want to know. Were you playing video games? Did you finish Elden Ring yet? Did you do anything regarding fun? Because I need to know. You're not talking. 𝖈𝖗𝖊𝖉𝖎𝖙𝖘. Of course. What is that? What is that? Please. I was kind of just like vibing for a second, so I am like understimulated. But I mean, well, earlier I did like a whole ad about like how cool math is. I'd be like, do you like math? Math is really cool. It's a free MMORPG by Nexon. Haha. That is pretty cool. I like MMORPGs. I really wanted to get into like, there's this one called Aura Kingdom that I knew of. My friends and I were gonna play it, but we ended up getting just too busy. Another one we wanted to do was I think Rift or Raft. I think it was Rift. Yeah, Rift. That one was something we were gonna do, but we ended up not doing it. Also, Zuzu, since you're here, you have your own exclamation point command. So if you exclamation point SUZU, Suzu, you have your own thing for my chat. Check it out. It uses that cool latex thing that I told you about. Yeah, the bellflower is here. That's what my little chat says, okay? Now, I have a bunch of other friends that have all sorts of different things. So if you look at my friend Penbu, it draws just straight up. He's a Tetris player and a musician. That is really cool. And the NEP is actually a really good one because it just draws stuff. So that is the power of math, and by that I mean this plugin. It's what we type with math with. So I can do something really cool right now with your name. I could be like, huge. Suzu is bestie. Okay. And I'm gonna put this in text because I don't want to break it. So watch this. I spelled that wrong. It's gonna be text. A little too big, I suppose. Maybe not huge anymore. Sorry. Math scares me. It's not that bad. Honestly, you just need to know how cool this stuff is. Suzu is bestie. And if I do double dollar signs, that makes it censored and it makes it really good. So actually, I think that's what I needed to do. So make it huge, but double dollar sign because it actually auto censors. Suzu is bestie. That's you. That's you. So yeah, that's what we've been doing tonight. I also just covered how to do a square root, like the hard way. So we're not going to cover that. But yeah, I like doing math stuff. My math content just involves me like not wanting to do like math homework, if you will. I like doing weird math stuff, and mainly I'm going to study to go back to graduate school. That's what I do. Because later this fall I'll actually take my tests and I'll go back to school, right? Suzu, you're a teacher. You should know this. Teaching is fun occasionally, and being fun and funny is two different things. So if students like that, then you should make the best out of it, I suppose. So yeah, and Tyler, I didn't expect you to still be up. So yeah, I'm gonna finish up the night just doing this shader real quick. And yeah, basically just vibe the night out, dude. So I don't know, I'm gonna make this bellflower blue just for you. That's what I want. Oh yeah, and you can explode people in my chat. I learned how to do that. So, all these wacky features and things that I just had fun with. So, thank you so much for rating. And I'm just here to vibe. I'm gonna do a mixed shader right now. I'm gonna combine this. I'm gonna make all these things look like glass, and if it works properly, then it doesn't crash. We did something a little more interesting, like a checker. Oh, you're in 𝖈𝖊𝖉𝖎𝖙𝖘. I'm so sorry. We'll tell you what, bestie, you should probably be subbed, so I can have you come in without any issue whatsoever. That would be good. Shucks, but let me see. There's only so many. If only someone could gift a gift sub for Suzu Amano. By the way, I do want to reach out to you pretty soon about some funny like collab stuff if you're interested. Saying it publicly, so you don't, you have to say something about it. And yeah, all that stuff. Fucking, excuse me. Sorry, Tyler. Yeah, thank you. There you go. You don't have to worry about ads no more. Thank you so much. Tyler works very hard, and he's very excited to let us have fun, I guess. So, that's just for you, bestie. Okay. And thank you so much, Tyler. Appreciate it. Wow. It's been a good night. It's been a really good night, So yeah, we've been vibing. We vibe. And I geek out, so that's the best part. So yeah, is this in the right order? It's not, because I put it in the wrong order. Oopsies. These also should probably have an emission. I need these things to glow. So I'm put these together. And they're gonna go into feed into here. And honestly, do I even need this in the first place? I don't need it to glow. These things need to be really nice. Tyler, you incredible bean. And bean, he's a bean. My colors are gonna come from back here, I think? Question mark? My ambient inclusion colors? Yes, it is. Okay. So here's what we got. We got this cool looking shape right now. And I can probably slide it a little harder. So the more glass it becomes, I don't know. That's not good. My index of reflection is not strong enough. Also, I'm running on like a toaster, by the way. I do not have the specs to even play any like things, let alone something as complicated as this. So, we ball, right? Let's do this. Color ramp. Let's do a ramp. So yeah, Zuzu, if you ever come by again, just like, I won't bombard you, but I'll definitely tell you a cool thing I'm doing. Yeah, we vibe. I don't want to scare the besties. Here we go. Colors. And then I want like a dark color of like green. Sure. How does the camera look like? That looks like buns. I don't like that. Do I have transparent on? Film, transparent glass. That's what I wanted. Okay. So the emission strength is going to be pretty strong for what it is. And then that way it compensates and everything else looks all right. If you want to make a math collab, I'm going to cry. Well, you might not believe it. That is like one thing I'm good at. So it's like saying I can't come in with like my best foot down. But hold on. Obviously, I don't want to intimidate you. I actually work with students all the time. So I am, in fact, a teacher kind of as well. Do not even stress. What I want you to do is ask questions. Don't ask questions that you think are impossible, because that's not your curiosity. You should ask questions that you want to do. Yes, fellow educator. Yes, I happen to be fit many hats. That is why I talk like this, because I'm very eccentric and the children like it. So we vibe. However, that also means that it is difficult. So it is kind of hard. And also, not just that, it's not just math teaching. I also do robotics as well. So it is a juggle. It is a struggle. But that's what we do, right? That's what we do, bestie. Robotics, yeah. Cool stuff. And by the way, this week I happen to have just done a whole bunch of stuff for work. And it cost so much of my time. Not in a bad way, but it was just like a lot of work. I just was very overwhelmed with everything. So I barely had enough time to even stream tonight. So that's good. And it worked out. Boy, this glass is not reflecting nothing, isn't it? Beckman. We're doing Beckman method, I suppose. What does that even do? I don't know. Make sure you rest. I do. I love your posts. I love your posts about enthusiasm and did you have a good day and what was your favorite flavor of ice cream? I like those questions. They're so honestly pretty cool. I hope the rest of you guys have a good night. Rest of the Vitamin audience enjoy themselves. I know a lot about you guys. It's nice to have a fan in the chat, I suppose. Did you have a good day, Susan? Yeah, did you even have a good day? You're not doing this for not good stuff, right? Oh, I know why it's not working. It's because I don't have enough light in my scene. Oh! Okay, that's too much light. Let's do 4. It was pretty rough, honestly, but in good spirits. Stream was good. That's good. You work really hard for streams, too. I noticed that. I don't happen to have too much time. I travel quite a bit. Not like for anything in particular, just work. So by the time I barely get around, it's like so hard. I'm like, ah! And it's not the bestie, but I barely had time today. I had to cancel one of my morning streams because I just had to do a lot. So yeah, and you too. Yeah, that's what happens when you live in the Pacific, right? Shoot. That's what we do. That's why I'm still up. I had an abysmal 1:43 in the morning. This is not turning out the way I want it to. And by any capacity. What's going on? Okay, I won't do anything transparent. I won't do anything glass. I guess that's not working the way I want. Oh, duh. I just realized why. Duh. Didn't even connect the stupid thing. Okay, let's see how this looks. Looks a little better, I guess. This might be something I have to render tonight, and then I'm gonna post it in the morning. Nothing crazy. It's just gonna be like a wow, wow, wow. And music is putting the vibe out too. So here's what I'm gonna do. Synopsis. This is the original shape. If I can make this thing look good, then everything else will look good. So then, here's what's gonna happen. It's gonna go from like square shape to this shape. And then I'm gonna have another key where it's gonna go from this shape to this. Wait, hold on. I just did that. To this shape. So if I combine them together, it's gonna do something wacky. And that'll be it. And then it goes back to a cube. I think. Yes. Okay. So key point. It's gonna go forward several frames. You're gonna become wide like that. Wow. Good key point. Animation is fun. That's what I really like. Then I wait a few frames. Then you start too. And then I'm gonna release this one. I'm gonna go back to the other one. I'm gonna go back here. I'm gonna go to here. Key point. So how does that look? Wow. Absolutely amazing stuff right here. this one, and then it's gonna go back to the original. And then it would loop, and then I can have that as a wacky animation on the twitch.television or something else. That's good. And then, yeah, I guess I'll leave that as the night's project. My only issue is the background. Oh, I know what I can do. I've done this before. So it's just going to be this, except I'm going to extend this out a lot farther. Where am I at? From the origin. Of course, everyone knew that. Okay, now it's not working. Oh. Justin Television. Yep, the one and only. I wasn't even around for that time. I only got into watching Twitch because I wanted to watch VTubers while I was preparing for my debut. Kind of funny, isn't it? Okay, so what I'm going to do is I'm going to raise these ends. In the Z axis. What's my 𝖘𝖔𝖈𝖎𝖆𝖉𝖎𝖙𝖘 right here? Oh. 𝖘𝖔𝖈𝖎𝖆𝖍 is all the way back here now. Okay, so now on these ends, I'm just gonna bevel them with a proper bevel profile. Hold on. This has got the width, segments, stuff like that. Shape, that's what I want. The shape is gonna be a little different. Yeah, because rendering wise, it's gonna like that a bit more. So maybe not a sun, but I'm gonna make these into spotlights. If I do that, it's gonna illuminate everything. Okay, I need a light of about like 5,000 watts right here. That's too much. An area light is what I wanted, my bad. And then I'm actually just going to take the one that I did have, and then I'm going to make it a little better. There we go. So you can see the actual area it's covering right here. Okay, now we add all the fractals on it. And this will crash my computer. Let me also spin this around a bit. Why are you fixed? Oh, this has the tracking. I don't want the tracking. Okay, so if it looks like this for a second, how does this look? That looks pretty good, except I just realized this entire thing is still too short. Oh, I know what to do. I will... Oh, no, I don't know what to do. I guess just eyeball it. So if it reached all the way down here... Wait, no, it still would matter. Okay, we got all this right here. So fractal will go wide. Wow, very cool. Oh, I realized that's way too close. Should I start with this? That's so off center. Or should I move the camera to here when it zooms out? Frame 50, I believe. And then I start closer here. So then here, what I have is, it's gonna go a few frames in. I'm gonna zoom out a bit. Or I could just go into material view so we can see it a little better. Yep, that looks cool. And then what, I zoom in a bit. Does the perspective really work there? Yeah, and in true looping fashion, I will just take the last keyframe, so it'll start from the very beginning again. Yeah, I guess so. It'll be good. Oh, and another thing that I can add too is I can add a random displacement. So I'm going to do a new key, and this is just going to be a mesh. Hold on. Transform, randomize. So maybe a few. Different seed, not uniform, not normal. This looks good. So then this and this can combine to change it up a bit. It's going to start with none. And while it transforms, it's going to look a little wacky. Okay? So maybe it's going to get a little big here. And then keep going over here. It's never going to look the same. And then it's going to look a little too wacky over here. But at the points I really need them to like look good. So at all the markers, they're gonna actually just stay as 0. Okay, and then what I can do next is I'm going to do a change in focal length. So actually, to prove the point that I'm actually starting from the beginning, I'm going to go over here, increase the focal length. What happened? As long as it's cool. So I'm going to do that cool little lensing effect, if you will. Mm-hmm. $28.1. Okay, and then go down to the animation frames. Camera frames are going to be a lot more back. No. Bezier. Or should I do linear? It's to be weird. Linear. Elastic? No. Assign new soil. Ooh, one more thing I should do, color-wise. I wish I could separate X, Y, and Z. Come on. Crap. Transform? It looks cool, doesn't it? Texture coordinate. Texture coordinate tells me that I can go anywhere. Let me do object occlusion. And also check this so I don't break it. My neck hurts. Oh yeah, these frames though, I really want these frames to be like way bouncier. So, why is it doing this? Oh, texture painting. No, these ones are going to be a lot more weird. Or at least some of these ones. I'm going to do some bounciness right here. I'll do an exponential. I'm really just playing with lots of these. Oh, I can identify which ones these are. And I gotta make sure they all go back to 0. Bounce. Reminds me of the Watchmen meme where he blows up the guy. So sad Steve Jobs died of ligma. Who the hell is Steve Jobs? Hold on. I got this. Hold on. It's so sad Steve Jobs died of ligma. Who the hell is Steve Jobs? Ligma balls. Boom. Sorry. It's a feature I have on my mixer. Let's just play with these wacky numbers what we get. And by far the best meme I've ever counted. Ever came across in a gentrified sense of humor. It's great. It's pretty good. It's pretty good. What happened here? Why did it? Oh, okay. Oops, wrong one. Keyframe 1. It's right here. I'm gonna make it bounce. These ones are gonna be exponential? No. Does it? And then I need the camera to actually like keep up, bro. Like what's going on? From here to here, I don't want this transform to suck buttons. So what we're gonna do, we're gonna make this transform. I'm gonna zoom in a bit. Okay, so if that's the case, I'm going to make this thing go zoom out a bit. That works.